All right, good morning, everyone. Glad you could all make it, both either online or in person. My name is Bruce Belzowski. I'm the Managing Director of the Automotive Futures Group here in Ann Arbor, Michigan. And I'm welcoming you to our second it's our 16th annual Future of Automotive IT. It's our second AI in the Automotive Industry Conference, following up on what we did last year and at the same time. Last year, we learned about AI in manufacturing situations, in-vehicle generative AI, and challenges in using AI in autonomous vehicles. This year, we'll hear from auto manufacturers and suppliers about how they're implementing some AI processes, as well as how consumers feel about some generative AI applications. Let me talk a little bit about the Automotive Futures Group. As I said, I'm the managing director. I'm retired from the University of Michigan Transportation Research Institute. We're doing this independently since 2018. Our conference has started back in 2008, so we've been doing this for a while. Our funding comes from our affiliate program, and we also have supporting members and research partners. It also comes from our research projects that are focused on globalizations, powertrains, and IT, and our 5 annual conferences. Here's a list of our affiliate members. We're also always looking for new members, and we will be talking about a little bit about this just on the next slide. So the benefits of affiliateship is you get early results from our research projects on propulsion strategies, information technology, and globalization of the auto industry before they're released to the public. All people in your company get free attendance at all of our research conferences here at the U of M North Campus Research Complex, but all of our conferences are hybrids, so people can join online as well. Usually we'll have many more people, probably 3 times as many people online as we do in person, but we still have people in person. We also deliver state of the industry presentations to affiliate companies. We take members' questions on our sample of industry, manufacturers, suppliers, government, academics, NGOs, and consultants for our research projects. And new for 2024 is a 20% discount of classes at the U of M Executive Education Program, the Ross School of Business digital and open enrollment programs. And this is their slide about their sustainable leadership program era that is just starting next week, and it's in September, again in March. Again, a 20% discount to Automotive Futures Group affiliates for this program. As I said, we've got research partners, IT organizations, OEMs, government NGOs, as well as suppliers and consulting companies. And when you look at the projects that we focus on, one of our main ones is the EV evolution strategies for the propulsion strategies for 21st century project. We just finished the one on the future of batteries. The one coming up is the future of charging. Our EV evolutions program is this is on our website, where we're tracking the policies and technologies for EVs in China, the US, and the EU. Again, I said that's on our website. It's also posted on our linked information from this is also posted on our LinkedIn site. And also the future of automotive IT, and this is what we're going to be talking about today. This year, in February and April, we focused on supply chains, sustainable supply chains, as well as nearshoring and reshoring of supply chains. And then on November, we'll have our 17th annual Inside China Automotive Conference. We're made up of our researchers, Kara Elkire, who is online today on the monitoring the YouTube stream. She'll be taking questions from the chat and sending those to me so that we can have those in the ask those questions to our presenters. And Sherry Nettler is with us at the table, as well as our student researchers. We have a new group of university research opportunity students, usually freshmen and sophomores that are be working with us this year. We're interviewing them right now, probably making decisions and having them start joining us next week. We've got, just from my interviews so far, I've got one or two students who are mechanical engineers who are interested in interested about working in the automotive industry. So if you or your companies are interested in reaching out to them, let me know, and we can make the connection. As I said, we've got a LinkedIn page. We're posting 2 to 3 times a week, sometimes about things related to our conference and what's coming up in our conferences. And then also you receive updates about the conferences and the speaker events. And also there's some exclusive research ahead of future conferences. As I said, our next conference is November 13th, our 17th annual Inside China Automotive Conference, the first conference that we did way back in 2018. I'm sorry, 2008. Let's go back a little farther. So for this conference, we've got a great set of speakers. David Anthony John from Nissan Corporation is going to lead it off. Alex Pham is going to from Toyota is following him. Then we'll take a break, and Alex Euler from SPD and Johannes Rickenhaken from FEVIO is going to be joining us. As I said, we'll do a Q&A after each speaker. The other speakers may or may not be joining us to participate in these Q&As, but they can do that. And we'll be ending around 12:40 for lunch for the people who are here. Attendees people who register get a link to all the presentations and the video, but the affiliates get all that, plus they get a summary and a review of the highlights from the conference. So the agenda, speaker bios, registration list, sponsorship opportunities, affiliate information, upcoming events, all on the Automotive IT 2024 Future of Automotive IT conference website that I sent the link to you in your email. But audience questions we'll be putting out the cards for Q&As that Sherry will be picking up here. Kara will be tracking those from inside of the chat. So if you have any questions, feel free to do that. Let's talk a little bit about AI in the auto industry. As I said, we did this last year as well. And so it's been a year. And when we did it last year, AI had in its probably in its full bloom with ChatGPT had started about a year before that. So now we've got companies are a little more involved in it and doing more things with it. So it'll be interesting to hear what they have to say. When we look at AI in autos, some people look at it as artificial intelligence, as the ability of a machine to imitate intelligent human behavior. Machine learning allows the system to automatically learn and improve from experience. And deep learning that uses complex algorithms and deep neural nets to train a model. But when you're doing AI, you do have to deal with skills needed. And there's process and automation engineers, data scientists, IT and data engineers, as well as AI creation experts and translators. Something that most companies, not just auto companies, do not have in-house, but they do now. So when we look at it, it covers a variety of opportunities for AI, right? Autonomous driving, sales and customer service, advanced driver assistance systems, in-car experience. We'll be hearing about that today. Manufacturing and supply chain management, as we'll be hearing about that as well. So when you look at the ADAS opportunities, you can see that it's interesting to see, and there's always some challenges in dealing with adding AI to what is already a system process that they've been already doing. And then it'd be interesting to hear how that might be changing because of AI. Autonomous driving, has a variety of things. The big issue being sensor fusion in terms of bringing all the different sensors to into play to make decisions about how a vehicle should drive. And as you can see here, there's a variety of algorithms that need to be that can be and need to be used for autonomy. In terms of manufacturing, predictive maintenance, quality control, these are things that automobile companies already do and their suppliers already do. The idea is, how does AI actually improve on this? It's not that these companies haven't done this; they've been doing it for decades. The question is, how does AI improve this? Supply chain management, where you're looking at suppliers. These are issues that we'll be talking about as well. And again, this has to do with efficient data analysis and insights for market intelligence and the need for all the data processing and cleansing, the pattern recognition and trends that AI can help with within the company, and also at supply base, and also even in the dealerships. It can help with supplier selection from a variety of areas, kind of bringing together all these opportunities or these metrics that companies use for making supplier selection, and also for managing the relationship in terms of performance tracking and analytics, scorecards, bringing all this stuff together and be able to do analysis on this. With AI, I think, is one of the things that they're considering. And then you get into the in-car experience, which we'll be talking about some today, especially in the second part of the conference, where Alex Oyer is going to be talking about some of the research that they've been doing on consumers and AI. And then Johannes Rickenhagen is going to talk about how FEV is transitioning from a company that is basically, we've always considered a powertrain company. And they still do powertrain, but they started to do more hardware and software and making different acquisitions and making changes in their companies. And they're not the only ones who are doing this, but it's be interesting to hear his take on how they went about doing this. So they're working on in-car experience as well, with some of the things that we see here with voice activated features, personalized assistance, auto diagnostics, entertainment, as well as home integration. And then you get into the dealerships, right? And then you're looking at virtual showrooms, price optimization, ways of dealing with the customers. And there's a quote that we picked up on: by using AI and advanced analytics, automakers can develop a sophisticated market planning and allocation approach that improves planning and quality and flexibility, delivers the cars customers want, and increases total profitability in the range of 15% to 20% across models, markets, segments, and channels. And then there's Gen AI. And so one of the variety of opportunities that we're seeing for generative AI, we'll be talking about this second part of the conference, looking at car manual FAQs, recall eligibility, roadside assistance, predictive maintenance, in-car virtual assistant, and design optimization. A lot of this is really focused on what's going on inside the vehicle and the relationship between the car and the driver, but also by extension the automotive manufacturer and supplier with the driver and the customer. So it's a thing that in a way that we really haven't seen before in terms of the potential and that this AI, generative AI, offers. And it'll be interesting to see how this is going to play out over the longer term. So when you look at AI, there's lots of opportunities. Reducing headcount in certain situations, to complement workers, writers, researchers, and artists. It can increase research speed in all the different areas that we've already talked about, and improve the quality in manufacturing. It could put in AI watermarks to recognize deep fakes that are a potential with AI. Digital forensics, also turning brain activity into speech obviously in a more advanced situation, and improving autonomous vehicles and AVs overall. But there's tons of challenges. There's disinformation in print, video, and audio. It's hard to separate sometimes truth from fiction in generative AI. And there's privacy issues, especially when you're talking about the relationship between the driver, the customer, and the vehicle, and then by extension, the manufacturer and suppliers that are part of that vehicle. There's a balancing the need to progress with AI while protecting sensitive information and maintaining public trust. They think this was some of the quotes we have. They say that remains a challenge. Another quote was that AI is still very new and governance will be very important. Ethical concerns, bias in algorithms, and the risk of misuse are some of the drawbacks to advancing the technology. Some of the other challenges include energy intensity for using AI, and of course some of the situations about supporting terrorism. We talked about the advantage of reducing headcount, but there's that a challenge becomes job loss as well. And there's in all IT situations, it's always a garbage in, garbage out situation where as the technology develops, it'll be important for developers, practitioners, and users to strike a balance between innovation and responsible deployments. We must also not give in to blind acceptance. Critical thinking will be important to ensure that informational integrity is upheld. And this is where I see this is where humans come in. You can run AI programs to generate information, to do analysis on things, but you need humans who understand the topic to be able to sort out and say, I don't know if that's the right way to approach that, or be able to ask good questions within AI rather than just estimating. So also a couple of the other challenges, when the genie's out of the bottle and we're going global, it's kind of reminds me of the science of genetics and the way that genetics has changed in some ways that would actually allow companies or governments to actually start doing not just genetic testing, but genetic be able to manipulate genes within people. This is a scary part, and since AI is going to be global, it's really being used already across the globe in good ways and in bad ways. Regulating without stifling innovation is one of the challenges. And it also, AI lacks capacity to understand cause and effect. These are some of the main challenges that we'll be talking about, and we'll probably be talking about them for a while as the AI story continues. And finally, despite the advancement of AI within the manufacturing sector, businesses are grappling with challenges in strategy and execution. The primary hurdle is the absence of a unified AI roadmap. Teams often work in silos, creating services and applications without a centralized vision. Only a minority of businesses possess a concrete AI strategy. We could have easily had said this at the turn of the century about IT processes, because you would have new IT processes that were being used in manufacturing, but not in product development. Some in product development that were not used in manufacturing, and that there was no real huge drive by CEOs. There were CIOs who were trying to do this, but there was no huge drive by CEOs to do this. And I think that would be curious to see how AI is going to be played out within organizations. One of the questions we can ask our speakers today. So that's all I have to say on this particular topic at the moment. I'm going to bring in our first speaker. David, are you still with us? There he is. All right, let me do a quick intro for you, David. I mean, James. James Anthony John is an AI and innovation leader at Nissan Corporation. He's been there for about 6 years. He comes to us today from Bangalore, India. He's also worked with Mercedes, Renault, and Magna Steyr, all in India. His bachelor degree is from the Government Engineering College in Thrissur in India. Welcome, James.
Thanks, Bruce. So I'll start sharing my screen.
Yeah. Okay.
Hope my screen is visible.
Looks good.
Hello, good morning all. I'm James Anthony John. I'm an innovation leader at Nissan Motor Corporation. So I work with Nissan Motor Limited, the headquarters of Nissan Motor Corporation in Japan. So currently my work location is based out of India, but I normally have our line of reporting into Japan. So, giving a quick overview about my career, I started my professional career at a design studio at India. So, as part of a product design and industrial designer for various design studios, when I started my career and moved to Magna Steyr. Magna Steyr is a contract manufacturer who works for different OEMs across the globe. I was a transportation designer and a studio engineering professional who worked with multiple OEMs at that point of time. I moved to Renault, where my role was within a lab called Lab Corporate Innovation LCI Design Studio, where I was part of the future mobility research team working on advanced engineering topics and trying to, forecast some of the future electric mobility at that point of time. So after 3 years stint at Renault, I moved into Mercedes-Benz. I was an electric vehicle architect who was part of Mercedes-Benz front wheel architecture vehicles. I was also leading an advanced product creation team at that point of time. Especially within Renault and Mercedes, I was part of the series manufacturing or mass manufactured vehicle, taking multiple responsibility. I was part of Mercedes-Benz, Stuttgart, German team, who was part of the early adopters of electric vehicle ecosystem. So having experience across different value chain of the industry, I moved to Nissan as an innovation leader, leading digital transformation for a different value chain of the industry. So what I'm good at is I'm best of both worlds. I would say I can connect the physical worlds, especially the vehicle hardware components, manufacturing process, or whatever design related stuffs going on the vehicle development and the digital world, where we have a lot of trends within a digital world in terms of software defined vehicle, different AI platform and analytics. Having a good understanding about the vehicle development process in the hardware and physical world and connecting that with the digital vehicle transformation, that's something what I'm trying to do at Nissan Motor Corporation right now. So today I'm going to deep dive into generative AI specifically. So most of the folks here in the conference may know about generative AI, but I would like to give a quick glance on generative AI. So what exactly I will be talking about in generative AI in automotive space. So currently, what I'm referring here is generative AI can be used for creating new content, such as images, videos, or text that resembles human content, human created content. So that's one of the very important aspect in the automotive industry, where different designers, engineers, or even the technicians at manufacturing layer, we work with a lot of contents. We work with a lot of newly created content for the automotive development. How a generative AI can help on creating the content. Also, how the generative AI works on the backend. It actually learns from the examples and patterns of the current data or existing data what we are providing, and then uses the knowledge to produce new and creative ideas. So, as an auto OEM, we all work on a large set of data, and this data has to be reproduced, re-engineered, and created in a different format. So currently, AI or generative AI and specifically uses very complex algorithms and neural networks to understand the patterns what we are providing from an automotive context. And this help us to generate new content, that is like the existing examples, so which can resemble to the future models or future trends in the market. So basically, we are trying to deal with a machine that can produce its own ideas based on what it has learned. So whenever we have a more learning curve or more data sets, the generative AI can perform well. Having said that, I'll move into generative AI in an automotive industry. So why generative AI is considered as a game changer for the auto industry? So currently, if you look into an auto industry, industry is going through a massive transformation, and generative AI is also trying to redefine how the vehicles are designed, manufactured, and operated across the globe. And within the AI capabilities, we come with a lot of traditional AI capabilities in the market for the last 5, 10 years. But generative AI is very niche into this segment, which offers new capabilities like human-like conversations, content generation, how you can try to get multiple perspective for a single problem, and it also increased the competitive advantage for an OEM. So early adopters are reaping benefits, streamlining their operations, reducing costs, improving the quality, and accelerating innovation. And from a market growth perspective, we are expecting to have around 25% market growth annually and to reach around 207 billion by 2030. So having these as an kind of catalyst for using generative AI in the automotive world, we started investigating on generative AI, Gen AI topics a couple of years back. So I'm going to deep dive into a few areas. So to give a automotive development in a nutshell, there are two parts to the automotive development. You have a physical vehicle development and a digital vehicle development. So the whole automotive development takes around 3 to 5 years based on the complexity of the product and the derivatives what are being created from the automotive. So, from a process side, we will start with the product planning, where the market survey, product concepts, advanced planning will be done to identify a product, a market, and a customer cluster who will be a potential buyer of a vehicle. And a design studio will come in where they will come up with a styling, design, color and trim, design prototype based on the planning feedback. So based on both design studios output and planning teams input, the engineering team, especially the R&D team, will work on vehicle integration, body engineering, trim engineering, the vehicle architecture, electrical integration, and even the software-defined vehicle principle goes into the R&D labs right now. Having worked on different models and engineering, background, we normally works for digital vehicle development till the engineering side and move into the physical vehicle development towards the prototyping, testing, and manufacturing. To reduce the timeline, we are also having digital prototyping methodology within a lot of OEMs right now. So prototyping is done for functional prototyping, design prototyping, for the module development, concept car development, which will end up in a testing cycle with vehicle testing, component testing, and competitive analysis, and move into the manufacturing. So having said that, different value chain of the automotive industry is very complex, and what are the generative AI use cases in this value chain? That's something what I'm going to deep dive. So primarily, I'll be touching upon product planning, design studio engineering in this session, and try to share my knowledge and exposure in the industry and how Gen AI is applied on different, these three verticals across OEMs. The first, I would like to deep dive into the product planning vertical or product planning value chain. So product planning is a team within automotive industry which plays a very important role in shaping a company's product portfolio, company's offerings into the market. So normally a product planning team conduct in-depth market research, try to do with a lot of data analysis, and this team ensure that new products are aligned with the customer preferences, market trends, and regulatory requirements. So if you look into customer preferences and market trends, the planning team works backwards. So if you are going to launch a car today, the planning team should have these details about the customer, preferences, market trends, and regulatory requirements 5 years back. So normally a product development cycle comes around 3 to 5 years, and advanced planning works for around 7 years before the product launch. So it's very difficult for the product planning team to understand the customer behavior trends, down the line 5 years or 7 years, and to provide the kind of input for an engineering team and come up with the objectives for the company. So this is going to be a very critical task for the planning team, and the planning team works with different stages. So primarily, the planning team works on 4 different stages in different OEMs. So they try to understand the market. So this is an initial phase where we try to involve the comprehensive assessment of the market environment. What are the economic factors of that particular market, demographic trends, government policies, consumer preference of a market? As an OEM, normally auto companies produce vehicle globally, and they have certain customer clusters across different part of the world. So understanding customer preference, trying to understand how the car can be sold to an US customers, Chinese buyers, or European customers, that's very important for a planning team to understand. And also they want to look into the automotive landscape. They normally does an automotive industry deep dive. The focus is more on to understanding the total industry volume or TIV, the kind of market segmentation available in different parts of the world, the kind of regulations which are coming up and which already have in the market due to autonomous electric revolution what we have. Emerging trends, probably the trends are very important to understand the customer mindset, how the unmet needs of the customers are defined and understood by the team, and also creating the profiles or the personas of future car buyers. So this is very important process in a planning where we are trying to build certain profile of a potential buyer, trying to understand his lifestyle, his unmet needs, and what are the key features he may need for a vehicle which we are going to build after 5 years. This will move into market deep dive with Gemba visits to gain first, the kind of insight directly from the customer. This is kind of a primary research we'll do with market dynamics and consumer behavior. And there will be a specific team which will conduct on-site visits of Gemba walks with dealerships, retail outlets, and specific location where we are trying to launch the cars. Completing these 3 phases or 3 stages, there will be a portfolio creation and product lineup will be created. So based on the findings of these 3 stages, the planning team will develop a comprehensive product portfolio consisting of different segment of vehicles, different body type, different powertrain units, and identify new potential, product portfolios or product lineups which can align with emerging opportunity with new market or new, customer clusters. So the intention of planning team is to have a high growth and high benefits within the organization. But how the planning team is working with the large set of data, what they have. The planning team is facing an explosion of data from various sources. We have companies who support research materials for planning team, coming up with customer preferences, trend analysis from different part of the world. But it's very challenging for the team to come up with a meaningful insight for a product which they are going to plan after 5 years and to understand the market intelligence at that point of time. So the solution, what we have been, working on, or what we can provide from an auto OEM side, is integration of data analytics and generative AI, which can streamline the process and also provide an actionable insights in a timely manner. So basically, what we are trying to do here from an problem or business problem perspective, there is a lot of data around the team, and there's no enough insights. So this goes into the manufacturing and sales line too, where the planning team and manufacturing sales combine a lot of data, and the insight generating an insight is very difficult. And at certain times, there will be data duplication where we are getting the research material on same topic from different agencies or different companies who are supporting us in the planning activities. And we also have certain data which considered as trusted, neutral or not even trusted from various sources. So identifying the data, coming up with a solution is very important for the planning team. So how we can use a generative AI to turn this data available within the organization into an actionable information. So that's something what is very crucial for a planning team to reduce the timeline of the planning activity and come up with a better product portfolio. So the first step is to gather data, collect information from different sources, as I mentioned, sales, research material, customer feedback, voice of customer data, social media, and certain feedback we are getting from the new age media. But it's very important to clean and organize this data because the data has to be very accurate and easy to understand for an generative AI model. So when I say clean and organize, the data duplication, removing the noise from the data is very important for a Gen AI model to perform well. And we have to give a context to a generative AI model, teach a Gen AI to recognize the patterns and trends in the data, give the context of this data to the model to perform well and come up with certain insights. So having trained this Gen AI model, it can generate insights which can be used for planning team to come up with customer preferences, the future market trends, and potential problem. So this eventually helps the planning team to make better decisions to improve the product quality, marketing, and business performance. So this is one of the very important use case the planning team will be using within different OEMs. So this is the same across different OEM across the globe, and this is something which is very important to run from a data analytics perspective. So the benefits, what we can expect from these kind of converting the huge set of data into insights are enhanced decision making. As I mentioned, data driven insights are very important to take informed decision for the top management regarding the product development, and also coming up with marketing strategy and product portfolio strategy and the resource allocation. All of like there was an electric vehicle revolution which started back in 2010, and there was not enough resource, so the manpower allocation was being planned for most of the OEMs. So these kind of data was already available in at that point of time, and we were not able to provide insights on coming up with a proper workforce which can take on this activities. Also improving the efficiency, automation of this data analysis, because this data can be generated every month, weekly or bi-weekly perspective from different agencies, and how you can automate this data analysis, coming up with a reporting task which can reduce the manual effort. So we have hundreds and thousands of employees working for planning activities and marketing, and how we can build an automation for analyzing this data and how we can integrate with some of the mainstream system. So this can reduce the time to market, and we can have a better product in the market within a shorter time frame. And this eventually build the competitive advantage for any OEM where they can leverage advanced analytics to identify the trends and opportunities. Overall, what we can expect from these kind of Gen AI based solutions are improving the customer satisfaction by delivering the personalized products, services that meet customer needs and preferences with the data what we had from the planning team. So as I mentioned, as a OEM, every OEM try to build a product globally, and they have different clusters of customers from different part of the world, and how we can understand the customer preferences from the large set of data, how we can provide a product which can cater their lifestyle. That's very important from an OEM's product portfolio. So that's something what we can expect from an AI driven model for the planning activities. But there are a lot of limitations when you look into this particular model. As Bruce explained, generative AI is a very new technology in the market, and the limitation what we feel within many of the OEMs are there are a lot of information about the data sets what we are used to train the models, because it can understand the data. But what are the biases it may have? That's something which we are not very sure. There are certain technologies which normally companies use to make it more contextual within use case and try to understand on certain areas. And also many of these models keep hallucinating. So there are a lot of technologies and techniques to reduce hallucination, but the contextuality and consistency is one of the limitation we feel within, within the early adoption of this technology. And certain times it tends to write incorrect content or come up with incorrect summarization, certain points with a high confidence. So it's need a certain level of manual intervention, try to understand the context, do certain manual testing before launching into a larger audience. So that's something what we tried to understand as a limitation. But having said the limitation, the advantages of benefits are so high, and the planning team can benefit these technology for streamlining their operation within any organization. So moving to next, area, it's known as an design studio activity. As I mentioned, I started my career in a design studio, and within design studio, it's very difficult for a designer to come up with multiple concepts at a time, and the creativity and flexibility of a designer is limited to a certain extent. So how a generative AI or AI-driven design can help a designer to accelerate the product development or accelerate the design of a vehicle. So that's something what I would like to deep dive. So if you look into automotive styling, styling can again divided into 5 phases where it started with an ideation and concept. As a designer, I used to brainstorm ideas and create initial sketches along with my colleagues in a design studio. We'll consider market trends and customer needs purely from a design point of view. We'll try to understand the form factors which can be, a kind of a trend in the market. What are the kind of materials, CMF or color material and fabric, which can be trending across the globe. So this is very important for a designer to start sketching and move into CAD modeling or 3D modeling, which is known as CAS, computer aided surface design, where we create digital models of the car, try to understand the perspective in a 3D environment. This is try to design some level of comfort and function within the vehicle. So the vehicle comes as a certain package or the volume. So this is something where the designer can help the R&D team to come up with certain volume analysis. Physical modeling and refinement will come after this 3D modeling, and we'll get into material selection and testing. As I mentioned, CMF, color, material, fabric is very important for an automotive when it comes to a design, and this goes into final design and approval. So what is the role of generative AI in the design studio? You can look into an AI generated content, which can use for to enhance creativity. So currently, the generative AI based content can serve as a powerful source of inspiration for designers. So for a designer will be inspired for certain components. He'll have certain inspiration from not only from auto component but from the nature itself. How an AI can generate certain inspiration based on combination of multiple components, and how it can provide unique and unconventional ideas. So that's something which you may be very much experienced with latest tool like Midjourney and Stable Diffusion in the market. But eventually, this AI tools can help designers to break free from their traditional constraints. So we'll have a kind of a boundary condition defined within the designer's creativity. So this AI generated images can explore new and different possibilities, or new and kind of an complex possibilities that designers might not be able to think. So one of the example I would like to share is the AI's ability to combine elements like textures, materials, shapes, patterns in a different way, in an unexpected way, leading to a very creative and groundbreaking and unique design. So that's something what you can see across different design studios in the globe, not only with automotive design, but from an industrial and product design. This is very much used across the globe. So, having said that, how we can help a designer to increase the efficiency and innovation. So it create certain realistic renders. So from a hand sketch to renders, it takes around 2 days to 1 week to create a realistic rendering. But even with the generative AI tools, it's with a 5-minute job, you can create a 2D sketch into 3D rendering, and a lot of things can be even developed with an image to image training or text prompt you are providing to create an output. So here you can improve the efficiency and innovation. You can come up with rapid iteration, with the AI tools. Within the same design, you can try to, differentiate certain form and functions using the keywords or prompt, and you can also try to build adaptive design of a similar drawing with the help of a generative AI tool. So eventually, it will enhance the creativity of a designer. He can come up with a multiple perspective or different perspective of a design from from a creative side. So it can also automate the routine task of converting your 2D sketch or the basic sketch into rendering and rendering into different environment condition. So basically, the Gen AI tools can free up designers to focus on the strategic thinking and creative problem solving, which they may need for creating a wonderful and unique concepts. So currently, it can also be used as a data-driven design. So as all OEMs will have a design language, it's very important for a design studio to come up with a design language and design statement. So based on the design statement, design can be converted using certain keywords and then prompting, and also you can ingest the market trends and consumer preference based on these trends and design language defined by the OEMs. So basically what we are trying to do here is we are trying to build a future proofing design where AI can help the designer to stay ahead of the curve by anticipating future trends using the previous data or using the current set of data as in kind of a design language from the OEM and come up with a very unique and promising design. So that's something that's very important. So I would like to share a simple example which is already there in the online. This is an ultimate AI masterpiece by BMW designers. So BMW and Schickler, they have collaborated with AI expert Gary to create an AI generated artwork. So primarily the AI which is used for this art have trained around 50,000 artworks and produce a masterpiece that can blend with different artistic styles. And it is showcased based on a BMW 8 Series Grand Coupe, demonstrating the intersection of generative AI technology and the art in automotive design. So basically, if you look here, it gives different patterns of design and how this is converted into a exterior paint job. So similarly, there are a lot of this is a very new technology in the market. So you cannot see any live examples of how a designer is converting his sketch into a 3D rendering, or designers using a generative AI tool into a kind of design studio. So a lot of things are happening right now as we speak in different part of the world in the design perspective. So the next part is the future of automotive R&D, driving innovations with AI. So as I mentioned, R&D is one of the very core part within the industry where we have a very rapid transformation in the industry for the past few years, where the connected, autonomous, electric, and shared mobility or case has been producing very significant amount of data, which is used to improve the product development in terms of innovation, efficiency, and customer satisfaction. So what does the automotive data landscape look like currently, and how the generative AI is going to use this data for the product development cycle? So currently an automotive OEM is a kind of a source for huge data volume and variety. So if you take a product, there are a lot of sensors, telematics, in-vehicle system, which is leading to a very exponential increase of volume of data from different sectors. Also, the data what we already have from a previous vehicle development cycle, the data which can be used from different sources as a trends, marketing, requirement for the regions and all. So how this data can be used on this data analytics and insight for the development. So currently we are using, or most of the OEMs are using advanced analytics techniques to extract the valuable insight from these data and to use it back in the automotive development cycle. So how we are using it within different OEMs. So currently there are two parts to this problem. We are trying to use a data-driven decision making also data-driven engineering. So data-driven decision-making is an area where we try to analyze the massive data sets from different sources to identify optimal materials, designs, and technologies. The data-driven engineering, where we are trying to look from an emerging and critical enabler for innovation and competitiveness. So that's something what we are using along with the potential, the big data, what is available within the different organization. So currently with the data-centric automotive transformation, GenAI drives innovations with efficiency. With the help of generative AI, we are trying to build a diverse design option. Most of the OEMs are building a different or varied design option which can generate endless possibilities of design for a vehicle component design, vehicle assembly process, and so on and so forth. The data-driven design is also using a varied data sets. So when I say data sets, it's not only looking into the current data what an OEM have. It can also try to deep dive into the market scenarios. What can be an potential new material available in the market? How we can come up with a better integration model? How certain data can be used to enhance the performance, reduce the complexity of the manufacturing. So a lot of things can be driven by the data-driven design methodology, what is used by the OEMs. To enhance the vehicle performance, to optimize certain vehicle parameters, to improve safety, to come up with the more sustainable model, generative AI-based analytics are being used within the organizations. Material optimization, as you know, like there are a lot of new materials in the market, and the combination of this material in terms of how the vehicle design can be optimized and come up with a better product, and sustainable manufacturing is also being helped with the data-centric automotive transformation with the generative AI tools. Eventually, what we are trying to do here, we are trying to come up with a tailored or personalized customer experience, which can help an OEM to create the vehicle that meet an individual customer preferences. So when I say individual customer preferences, we are looking into different set of clusters like adventure seeker, or a kind of a soccer mom kind of person in US, or a contempt settler who is based on Europe. So each clusters will have different product requirement and unmet needs. So these data can help us as designers along with the R&D team to come up with a unique proposition as a product for these clusters. So certain benefits what we are looking from generative AI, it's providing the competitive advantage from an automotive perspective, which companies which can leverage generative AI can gain a significant advantage by reducing the product development cycle and coming with a high quality vehicle. It can also accelerate the innovation by automating a lot of design tasks and provide rapid iteration, and also build a better and faster innovation cycle. Fail fast and move fast can be applied using GenAI application. Enhance design efficiency through the simulation and analysis. There are a lot of CFD and other analysis happening within the R&D labs, which can we can use the generative AI to minimize the need of extensive physical prototyping, thus reducing the product development time and cycle. And also reduce the cost of the product development, and also brings the product faster to the market. Improve safety, as I mentioned, a lot of data is available from sensor fusion, autonomous drive technology, connected car. How the generative AI can use the connected car probe data and autonomous car data to help to identify the potential design flows, not only with the physical product in the software defined vehicle structure through this data set, and recommend improvement, ensuring the compliance with the safety standards. So that's a very important key takeaway from GenAI tools what we have. So that's an end of my presentation. So I would like to say generative AI is a very powerful tool which different automotive manufacturers are using right now to enhance their development process and stay ahead of the competition. So thank you all.
Thank you, James. Can you stop your share?
Yeah.
And let me turn on my video. Good. Uh, Very interesting presentation, James. You really looked at talking about some of the real opportunities. You do have one slide about the risks, about some of the challenges. Uh, when you look at those challenges and the risk, what strategies do companies use to manage the ones that you mentioned?
So, Bruce, if you look into generative AI, it's a very new technology in the market, and there are a lot of advancement coming up in a weekly or bi-weekly perspective. So the current challenges or the challenges which we have experienced, say a couple of years back, being rectified at this point of time. But one of the major challenge I would say right now is the consistency of the content what is generated, or how we can optimize a certain thing based on the contextuality what we are going to provide for an automotive background. And another challenge, which I would say, the data what we are going to use for generative AI, a bit, I would say these data are being used by different models, and we are not sure this data will be reused or reproduced for different contexts either. So having said that, the use of confidential data in a generative AI model is still, I would say, a roadblocker for a wide adoption of generative in many areas or many verticals within the organization.
Okay, thank you. How far along, when you look at you talked about a lot of opportunities. How far along do you see is the industry in implementing AI applications?
So there are a wide range of use case, within, if I can share here, the use cases what I defined from a product planning, a manufacturing and R&D labs to a design studio. These are very niche areas in an automotive cycle or automotive development cycle, which we need to customize or create a tailor-made application for different verticals across the OEMs. So the usage or the adoption of this technology is not, currently in a wider spread. As an early adopters, we have a lot of tools within the organization which works with, Gen AI techniques. But from a, if you look into chatbot, which can enhance an employee experience in an organization, we have a wider use. But certain niche area like image generation, content generation, it have a very limited use due to, certain confidentiality or the data compliance what we have. But if you take marketing and sales as an example, which comes into a post production, marketing and sales is an area where we are having a widespread of generative AI application where a chatbot assisting a potential buyer on, picking up the right model, coming up with certain recommendation, and after sales support can be done using an AI chatbot, etc.
So one of the questions from the audience was, how do you use Gen AI to train your data? Do you use a pre-trained model or a GPT to explore the different tools?
So it's all based on the use cases and the verticals what we are working with. So certain use cases we can use the GPT models, especially we have a GPT-4, the flagship model from OpenAI, which can be a plug-and-play solution for certain use cases. And we also use a pre-trained model and come up with better results. And there's also an option to train the model with a certain context, certain the kind of output what you need from a content generation or from analytics side, and create your own output for that. So it's all based on the digital maturity of the user, the kind of output the team is looking forward.
Very good, thank you. You talked a lot about the alternative design in your presentation. How will the designer's role change with AI in the auto industry?
So if you look into designers using AI tools, so there are a lot of tools available in the market right now, like Mid-Journey, DALI 2, and Stable Diffusion. So most of the designers use this tool to enhance some of their design, coming up with multiple perspective of the design. So there is no threat to a designer's job when you are very good at creating a net new design from an ideation perspective. This tool, generative AI tools, are used to improve the design in certain extent, coming up with certain enhancement in terms of material, fabrics and patterns. Also to convert the initial design or sketches into a 3D rendering. So which normally takes more time. So this can help the designers to reduce the design cycle and come up with multiple concepts at that point of time. So consider a designer is creating a design for of a vehicle in a week. He can come up with multiple designs, probably a 3 or 4 designs in a week with the same bandwidth. So that's how we are going to help a designer with a generative AI based image generation or content generation tool.
Very good, thank you. Let's see. One of the things that we see in the auto industry that's very challenging are recalls. Where you have, like I think BMW just had a braking recall that's going to cost them $100 million or more to either fix or replace. How do you see AI helping so that it reduces the amount of all companies have recalls, right? It's endemic, but they can be extremely expensive to do. How do you see AI improving that?
So Bruce, if you look into the recall, as you mentioned, the recall is very common in the auto industry. And what an AI can help within the recall is in having a very effective recall. Trying to understand the root cause of the recall, probably trying to understand or get the data from tier 1, tier 2, and even tier 3 supplier along with the manufacturing VIN number, and try to understand what was the process which went wrong and what was the product quality which was affected during this manufacturing process, and trying to limit the recall into certain number of vehicles rather than calling a certain number of batches of vehicle. So this data is already available within the OEMs, but to having an analytics done on this data, probably the recall may not be needed on different regions. To give an example, a particular part may fail in a region in US, may not have any effect in a Middle East product. Extreme weather condition may be one of the reasons for the part failure or the product failure. So that can be tracked with the data. And to have an effective recall, this can try to identify the root cause and try to identify the affected batch of vehicle. So that's first part. And second part is to having an informed decision to our customers, trying to make them informed about the product quality and to have a better customer experience during the recall process. So recall is considers one of the kind of an experience, or I would say we'll have a bad experience during the recall. We can enhance the experience through certain customer experience models and providing the right information to the customers at the right point of time. So from a product and service side, this can be integrated and can have a better recall management system.
So when you talk about recalls, you're talking about mistakes that were made somewhere along the way in the product development process, either in R&D, product development, even manufacturing process, right? How do you see AI actually helping to prevent the recalls from occurring? How do you see the AI processes in product development and manufacturing, R&D, in such a way that they don't make as many mistakes?
So, Bruce, I would like to give an example here. So, if you have a data of recall, it may be related to a part failure in a manufacturing line. And if you take a historical data of that particular manufacturing line, we can understand at certain point of time or certain cycles, these kind of machine errors may happen. So this is the data which we already have as a historical data, and using this data in an AI model, try to predict, there can be a product manufacturing defect which can come up after this cycle and have a predictive maintenance before this happens. This can probably avoid this kind of malfunction in the machine, also to have the better product rolled out from the manufacturing plant. So we can do certain predictive analysis or predictive maintenance for the set of manufacturing line based on the historical data with the help of an AI to eliminate these failures in the future.
Very good. Thank you. A couple of final questions, kind of focused on the future. In what part of the industry will AI be most transformational? What are some in the next 5 years? Which part of the industry do you expect to see the most growth in AI?
So if you look into the vehicle as a product, there are a lot of things involved within the development process, and we are moving into software-defined vehicle within different OEMs across the globe. So in a software-defined vehicle, an AI plays a crucial role in coming up with a better strategy, foolproof design, and better options and models available for the development cycle. So that's one part I would say which can be challenging for the future within the generative AI or AI space. And second would be the experience part. So within the auto industry, we have two kind of experience, the onboard experience and the offboard experience. Onboard experience is your in-car experience, currently seasoned with all your digital experience channel. We would like to have a seamless experience from your devices to in-car. So this is also conditioned by a lot of AI stuffs within the industry right now. The offboard experience, how you are controlling your car with a connected app. So the dealership experience you have during your service intervals or buying time. So that's something where the AI can play a crucial role and enhance the experience from a customer perspective. So I'd say SDV and customer experience can play a vital role within the automotive verticals in terms of AI and generative AI.
Very good. I think I'm going to let you go on that, James. So one of the questions that came from the audience, and it probably will be, it's also of interest to people who are online, is will they receive copies of PowerPoint presentations? Those will be on the website this weekend, as well as the edited video. Okay. Alex, you with us? There he is. Good.
Yeah.
Welcome, Alex.
Hi.
So Alex Pham is the General Manager and Chief Architect, Head of Data Infrastructure and AI Platforms at Toyota North America. He's been working with Toyota for 8 years. Previously, he worked with Visa and SanDisk for a combined 10 years in IT and Chief Architect and Senior Director of Development. Started his education, the BA in Statistics and Computer Science from San Jose State University, and he supplemented his education with courses in the National University, Santa Clara University, Stanford, and MIT. Welcome, Alex.
Hi. Can you hear me well?
Yeah, we can see your presentation. We see you, and you're ready to go.
All right. Let me get started then. Okay. I'm glad that we do not have a lot of material overlap with Jane. So let's go ahead and start it here. Okay. So first, I'd like to have a disclaimer. This is to reflect my personal view and my opinion, not by my employers, because there are a lot of topics to talk about. So first of all, let's talk about AI and where AI is. And that is a quote from the CEO of the Alphabet. Say AI is probably the most profound stuff that we have, better than fire electricity. Dr. Andrew Ng say, it's hard to think of a major industry that AI not will transform. But more importantly, what say is by Dr. Kai Fu Lee. They say, AI won't take your job, but human who learn AI well. Since you are here, you are learning about AI, and this is probably one of the few things that we could do for ourselves. Okay, now let's look at the profession that we're at risk due to AI, and then you talk about all the Gen AI. This research is done by Goldman Sachs a little bit, and I will cite a little bit the example in the legal, but you can see computer and mathematical, 29% of them consider the replacement. And if you take an average on our industry, the percentage of replacement of the jobs is 25%. Now, that is high because you think out of 100 people, 25 people will be laid off, all 25 will be replaced. No, that's the bad news. So what's the good news? Now you look at all the industrial wave here in the past 100 plus so years. And so this is the first wave is 60 year, and then it create a pace of new innovation. And then the next wave is 55. As a more wave it have, but the portion the as a challenge of all this new wave is create a new opportunity for new occupation. For example, this are what to say. Since 1940, the area that we consider as professional is growing to over 25 million jobs. That doesn't exist between 1940 before. So AI will bring yet another industry changes, but there are a lot of opportunity to come with that as well. But the one that know AI will be better than the one that who does not know AI. Now, that gives you a little bit more context, but let's go through the information at hand. So, of course, if you look at Toyota, we're already working in Gen AI. Some of the news that's out there that you can research in the public space and Google and everything quite a bit. Now, so what I like to touch on is depends on how you categorize in the automotive OEM. You can take that data and you take it all this and organize them into different buckets. I organize them the way I see is most effective for me, at least in my term, which is basically a connected car, and then the driving are autonomous, and then consumer experience, vehicle design, how you build manufacture, and then the rest of them I would consider enterprise operation, which would include the legal, the sales, marketing, HR, and everything like along that line. And finally, you need that foundation because AI require data and infrastructure. It won't run without it. So first of all, you look at AI there is connectivity. We've seen some of that already on V2X and stuff, and I will talk a little bit more about that. Then you see again, oh my God, driving and autonomous, you have AI and customer experience. And then eventually, every single aspect in the auto industry have been touched by AI. So the conclusion is AI is pervasive and permeate across in the auto industry. And I will cite example I go along here so we can see quite a few of them of us. So let me talk about a very first one, a topic, which is connectivity. Now, the challenge here is you have a reliable network coverage or not. How do I know the car is in network and out of network? When it is down, imagine you were in the vehicle and suddenly you listen to Spotify and your Spotify isn't there, or is lower, or is higher, and then it disconnected altogether. Now, beyond that, on vehicle, what we want to achieve is a consistency in the customer experience. So you go down to the mountain, you go to the urban area, all this experience I need to be keep consistent for specifically for connectivity. So the communication across the medium, network medium from satellite, 5G, Wi-Fi are all critical in the connected vehicle. And what you want to do is not only that, but the communication. What if there is a pedestrian there? And what if there is traffic light? Do you know how long it takes you to wait for a traffic light? That's 1 minute, 2 minutes. What if there is an AI that can predict and tell you, okay, you are probably watching on the phone and it wake you up and tell you, okay, yes, time to go for that. Now, you also have connectivity from vehicle to home and all the charging and all the charging services. And then you connected to building, and more importantly, you connected to the cloud. The data are transferred over to the cloud, or V2V talking to each other. Now, in this context, you're talking about millions of vehicles in the Ford. So the scalability and the size of managing in millions of vehicles is this problem. Also, as the bandwidth and the data, how is the cellular and MNO able to deal with it? And on our end, what type of communication protocol, what type of network communication do we need to guarantee the delivery of the messages for both safety, in-vehicle entertainment, and as well maintain that connectivity? So you look at, as a researcher, where are the opportunity for research? First of all, you look at AI network optimization. How do I optimize the network within the region or within the contact, confined contact with us? How do I look at the reducing network data transfer? Because reducing the network data transfer means that we save tons of money. Instead, we save money by instead right now we pay few hundred millions on all the connectivity data to an MNO. If I reduce that by 30%, 50% or more, I would reduce the total cost of data communication. So you have to look at the area and say, what do I do and does for this? And I send the data and a lot of research for this already. For example, quantization is one of them. The other one is federated learning that you probably learn about. There are quite a lot of research topics there. So those are the opportunity that what we have to address this type of connected car and challenges or go over the vehicle. Let's say you do the lane merge changes. Who has a right? If you're talking one standpoint of geofencing, yes, a vehicle could protect itself and drive through it. But what if you can communicate with another vehicle and say, I am in urgent situation. Can you yield to me so I can go or something alike? So there are a lot of opportunity in this hyper-connected vehicle research that we could do. Secondly, let me talk about the second topic, consumer experience. What are the key consumer experience right now if you have a BEV? First of all, look at the battery range and the remaining useful life. How long does it take me? Is my car going to last 10 years? The cost of the battery is about 1/3 of the vehicle. So it's a significant cost. Replacing them or they have problem with that is also is a headache for the BEV owner. As you can see, there is a upward momentum on BEV, and now there is a downward momentum on BEV because some of these challenges that people are not addressing quite yet, including, for example, where do I charge? What type of data infrastructure do I have for as well? So then beyond that, the number one consumer complaint they have is service and repair. Everybody had to go into a service shop. They wait and they know the repair quality are not there. So how do I operate my vehicle? How do I easily operate my vehicle is another issue. Their vehicle get more and more complex, hundreds of buttons there. What are the experience that we are bringing to the consumer in this context? Then how do you plan the trip? From A to B. All this are required, and even the area of contextual understanding. I speaking with not native English, not my native tongues. But what if you have a different type of language? How is the vehicle understand all this and be able to translate in all those? So these are the area of opportunity that we should look at. The AI modeling for AI battery range and life, the LLM for vehicle operation, and I will go a little bit more about the LLM for service repair. For financing, so and loyalty and personalization, all these are the opportunity that AI and Gen AI could do for us in this from the automotive industry. So let me guide you through an example on this service and repair. Now imagine yourself working on the latest technology. You have to implement an AI agent within that AI engine within the vehicle. It's communicate and say, okay, it's tell you, okay, I want to go for service and prepare. Then it's connected to the cloud, and then they give you, and you have two forms of communication here. First one is to your mobile phone, and then the second one is to your vehicle. Now, it's not only launched the LLM with that, but also information technology is just about not about AI alone. but you take both the infrastructure and the application and combine together to create a consumer experience. In this context, you create both the consumer experience for the consumer and also the dealership, because when you're helping in a dealership in this context, before they come in into the service manager, you have others already talking, the agent already know and prompt, okay, what type of services, what type of repair needed, and automatically create an appointment and then send you an appointment as soon as you arrive your vehicle there. You do not have to wait. You do not have to go through the process of waiting an hour and talking with a service manager and then eventually end up in a technician and stuff like that. So all of this are enabling type of technology of what we could do within the vehicle. Imagine even more use case that even better than this. What if you have a little bit of the problems and they say, okay, now take your camera and use your camera to go and inspect around the vehicle where it is, or open the hood and find here what's wrong with it. And then there actually instruction that tell you what to fix. If you're not able to fix it because you don't know how or any reason for that, then just guide, okay, here's the next dealership, the option of what you could do, fixing them immediately, fixing them later, go to a repair shop, or go to dealership. So those are the contact examples of what we can enhance the consumer experience for. Okay, now AI also is not just limited in the connectivity of the consumer space. It's permeated everywhere, and this I demonstrated right here. Sales and marketing, legal, HR, finance, workflow automation, employee productivity. You already saw one of the public release that we transform our IT data services with Gen AI. Now, in the employee side, we also have Copilot, which ultimately every single email, everything you want to summarize, you can talk about it, and then actually help you to summarize and write some of the messages there. So I think it's a huge boost in productivity there as well. But look at all the one that I mentioned before, for example, legal cases or legal or IB research. We load in hundreds or thousands or millions of documents that related to cases our IP. And one of the things we want to do is, on our contract, summarize and organize this information to the way that it works. So it enable an AI assist to the legal teams. Also, for me, for example, if I want to do an IP to create a patent, what do I have to search before as a complex here and there? Now can actually talk about a Gen AI, and it's also create for me and say, okay, summarize, here's are the three patterns that are associated with us, and what you're thinking about. So it gives you the innovation and association with that. In sales and marketing, if you want to launch a campaign, you can ask Gen AI or anything like that. I want to launch a campaign in social network, YouTube, Facebook, some type of gender, whatever that is. It's have the capability and ability to do that as well. Okay, more on the talent resource management. Gen AI actually help you write the job description. And not only that, enable the employee engagement, but think more importantly as an employee of the corporation. Right now, what we traditionally do in this context is you want to search something on in the corporation. You actually tap in and go to the internet, and then all this website, the internet, some of them are 100, you have to click through and find the right information on it. What if that experience for the employee going to change? You were able to interact with a chatbot and an AI agent and enable that capability there within the human resource context. Now, further, the assembly and all the manufacturing process is fairly complex and not easy. How do you retrain? Gen AI enable the training capability such that you can have actually the employee and work through the employee through the instruction of training, make them more productive very quickly. On the finance side, of course, the revenue forecast, asking the revenue, asking for price dynamic, and finally with the workflow automation. So the enterprise operation space, as you look at underneath, beyond the vehicle itself, in fact, the entire thing from beginning of the making the car, the conceptual design of the car, what Jim talked about, and operated within the enterprise, AI, and all this are going on constantly within the corporation currently. Now, you look a little bit at logistic and supply chain, and you look at the BEV for a little bit, from raw material to end of life. You go through production. How do you track the first use of the car, and then you sell that car? Who has the second use of the second car of that? When you actually go to recycle the battery when you end of life? All this are AI enabling from traceability of raw material until end of life for it. You look at the vehicle and then the energy consumption. For example, your vehicle being charged and very high L2 or L3 and type of charges. How long does it take? The energy that is consumed in that context for that. So that need AI model and train underground to understand the energy consumption, the effect on the battery life. Safety analysis is another aspect. But then we want to be avoided on other safety issue. For example, if the aisle is too big and somebody stumble on it, somebody hurt themselves on the job, you have camera and everything like that, such that we capture all this footnote and run them through to analyze without a problem with that. The next one we talk about, and then both James and Bruce mentioned about recall. Well, one of the things that we do recall is how do you create an anomaly detection? An example of anomaly detection is like this. You take a paint job on the vehicle, and then you have the camera that look at all the single vehicle and identify defects in the paint job. So that's great. Now you have a defect in the manufacturing, and you don't understand why. The portion is one of the reasons, let's say, the mechanical arm over time are wear and tears. By wear and tear is will create defects on the part as is examining the vehicle. How do you detect that? That's also the portion in anomaly detection, and that will be able to reduce a certain type of recall, be able to detect things that's not exist today. Now, looking at another portion is how do you do the logistics? Okay, so last few years, we have a lot of people are working through and say, I have a vehicle, and Toyota in our dealership say, we can never deliver them accurately. Some of them wait 6 months, some of them on the year wait, some of them, but how do we tell them precisely your car will arrive 36 days from now, you're expecting that for that. You look at the logistic optimization from when we actually get shipment to the first point of port and go to the vehicle, the distribution center, and the second line, and then they go to rail truck and then the dealership. All this in this equation, and I just guide you one complexity in the area of your management. Imagine you have a truck that would have 20 vehicle, load 20 vehicle on it. As the truck come in, what type of car do we load on it? How fast do we load on it? Do we know what load that truck will be at? If we load our SUV, can it handle it? So before the vehicle come in, of the truck come in, we need to know exact the timing of the truck load. And then when the truck come in, we need to know, okay, exactly what we're loading. So everything has to be prepped before. How do you do that without a good AI and logistic optimization problem that what we have right now? Those are the key area that we enable. Even in the part prepare, 1 minute in assembly that cause a delay, you cost that cascade the efficiency down route the manufacturing route. So those are the area of logistic optimization we want to examine as well. And others could be enabled by AI. Now, one of the area that dear to my heart because I'm in charge of this area, data and infrastructure. And you look at the side of AI have been introduced over the year, and then all this take off very quickly with the Gen AI, such that the challenge of what we're looking at is scaling the AI. How do you actually scaling model? Can we actually constantly run the training model like in million, billion, and trillion of parameters and make them effective? Emily mentioned about the data volume and the data quality as well as the privacy. How is our data center, the power grid able to handle that? And infrastructure accelerating. Now, all these are challenges. Here are the opportunities. The search for the key opportunity is scalable AI. So imagine you have an AI Now it goes through 100 layer of decipher what it is. Can this be break out and then create you but same accuracy and faster performance? How do you guide that and how do you distribute it in AI workload? How do you optimize an AI? Because the AI, there are many different layers in the transform, for example. Can you substitute that with something different? Can you change some aspect of it to improve the performance for the AI? So you look at the detail of the AI model itself and try to optimize it or come out with the new type of AI model to improve do that. In the area of data processing, it's key. Everything is about data. AI cannot survive without data, but sometimes you have missing data. So therefore, what you want to do is create synthetic data, but you don't want to overuse the synthetic data because if you overuse synthetic data and you get the inaccuracy. But you look into the entire process of where the research could happen of improving the I/O, make sure they parallel. How is all this data interface into the GPU and CPU? When it's RAG, it's been used appropriately, and when it's RAG, it's not and even in the edge as itself. Infrastructure optimization, the LLM inferencing, where you use it in the rack. For example, for in the vehicle, you talk about, I want something like that, and inside the rack. Well, it had to go back and call and make a call back to the cloud and get the information for its contact. That's going to work. So all these are area that we need to concentrate about. So we look at the infrastructure and you look at the strategy. Do we want to go with the public cloud, hybrid cloud, multi-cloud? In our own data center, where do we optimize the compute, the data, and the algorithm? And underneath that, how does the network performance, the storage, and the GPU? All these are services, the application layer of what we have, what we needed for it. So at conclusion, AI is pervasive and permeate in every single aspect and domain of the auto industry. All of them are using transform the revolution the business organization for new researcher and engineer. The future is bright, and there are a lot of research and challenges that need to be solved still. For OEM, I believe that the rate of adopting AI, competition is really first. If you're not adapting to AI, the consequence can be severe. And that's it. Thank you.
Thank you very much, Alex. Very good insight. In particular, I liked your insight about the infrastructure story because that's you said one of your big responsibilities of supporting this, right? So when you look at how you're integrating big tech into the work that you're doing, you don't have to give me a number, but the cost involved in developing the infrastructure and the cloud infrastructure that is maybe not part of your company, but you're outsourcing that, right? To the AWS, to the Microsofts of the world. There's a cost involved in this.
Yes.
And it could be pretty dramatic. So
yes.
How do you balance the cost of implementing this technology versus the advantages?
Yes. Excellent question, Bruce. When organizations should need to actively look at it, we have great relationship with AWS. Public cloud is the way to go, but we have to make sure that some of the workload are not always fit for the cloud. Some of the workload, for example, probably better fit to be on-prem or in a hybrid mode. There are some of, and some of the concern about data and privacy. So some of them maybe the data is on-prem and served to the public cloud. So there are a number of different ways we're actually able to do this, not on the infrastructure side. Of course, the investment on infrastructure in the public cloud or in the private cloud will be substantial. And then you need to compare where the return on investment of what we can do with the public cloud and what we can do with the private cloud, and find the right AI workload and the right AI use cases that balance both the public cloud scenario and then the private cloud scenario. For example, in case of the logistic optimization, there's nothing out there currently, then we probably have to build something ourselves for that. So there are areas that we need to be consciously look based on the business use cases and say, this we could do it here much cheaper in the public cloud, and we could do it here in this context, and this is much cheaper. That's do it on-prem in the hybrid environment, or even go through with the partners. So it's one by one because the spend dollar, the infrastructure is significant. It should not be take one unilateral approach and looking at say, okay, we go through and spend all the money on the one area. That would be not too quite profitable for the company.
Very good. James, do you have anything that you want to add on that topic?
No, I think Alex have shared something what is an industry standard in the most of the OEMs. I completely agree with Alex on this.
Yeah, it's not like all the other companies are doing the same thing. They have the same challenge, but it's the balancing act. It's a balancing act about
Correct.
what are we going to get back from this for the costs. Now, it's not just the support from either connectivity or the cloud or just the energy use that is required for AI models. It's
Yes.
tremendous, and so that adds up, right? Not even including the people that are like yourself that are part of and your team that's part of maintaining it, right? And maintaining the relationships as well as maintaining the connectivity. So there's some interesting cost, I think, involved in this and in balancing it.
Yep.
Bruce, I'd like to add one point here. So if you look into the pricing strategy by different, service provider like Azure AI or AWS Bedrock or even the Vertex AI, this keep on changing. The pricing strategy keep on changing. So the cost involved is kind of a biggest hurdle for the adoption of AI in the organization, because we don't have a clarity on what can be the cost when we are doing a mass, transition into AI defined workforce in the future.
Very good. Thank you. Alex, how do you ensure a future-proof level of neural processing capability in the car's EE architecture to support its 10-year or more year lifespan without adding unnecessary cost?
I wish I could answer that one fairly straightforward because I don't even know myself. So, but I can tell you here what the area of what we look for in the car vehicle. And for that, if you look at the vehicle as just a laptop, and then they have the compute engine associated with that. And this have the different type of model, some of the high-end models, some of the low-end model. And then in this context, if this compute can only run so much type of services, and then at a certain point, it's only adaptable for that type of level, and this provide that type of services. If you want more capability than beyond that, then you need to have next generation for it. What we try to do is maintain, as you maintain the laptop or the PC desktop upgrade in cycle such that it maintain for 10 years, 20 years even. But you can never exceed the capability of what that compute power going to provide for you. Now, for example, in the first round, it maybe is able to run 10 AI agent, but no training by itself, no learning by itself. The next generation of compute in that type of context may be able to run and train 100 agents and run by itself. And then the network capability is better. So you look at all this aspect of it and say, we consciously look at this on the software defined element and also within the vehicle itself and say, okay, what could we do to make sure that it will work for the consumer in the long run, not just, okay, next year, let's do another upgrade. Yeah, upgrade will be costly. Also, building the vehicle in such a way that we think could be upgradable.
Very good. Now, this this story about being able to manage this, the complexity.
Yeah.
And some of the manufacturers are farther along. And I wanted to ask both of you about the interaction of AI with the software-defined vehicle. Now, this is something that Tesla has an advantage on because they started from scratch. So they were designing their vehicles with that from the beginning, whereas the traditional manufacturers have to do this kind of either at one starting point and say from then on it's going to be this vehicle is going to be, or trying to transition a number of vehicles at the same time. I mean, Tesla doesn't have 20 different models that it has to support. But how far along are we in seeing the interaction, first of all, of software-defined vehicles, and then the interaction of that with AI? Alex, let's go with you first.
Okay, got it. Yes. This is the difficult question, and it's an excellent question. Software-defined vehicle with traditional company like Toyota is definitely not simple because we always have different line, vertical line of all the vehicle and how we make them. So to create a software-defined vehicle is create a horizontal you call platform and be able to service across a number of the vertical. It will be challenging, or at least well, not only one, maybe one or two, a few, not a whole lot like what we have right now, because it's not scalable in that context. So software-defined vehicle is something that Toyota taking very seriously. In the process of working and doing this right now, I cannot share a lot more detail on that, but the journey has begun.
The journey has begun, right? Okay, very good. James, how do you feel about that topic?
So, Bruce, if you look into most of the OEMs, other than the new age company like Tesla, we come up with a very traditional old school style of the product development. And as Alex mentioned, so we work in a metric style of organization, and this SDV or software defined vehicle cuts across different vertical of an organization, starting from your R&D, manufacturing, connected car systems, marketing and sales systems, as well as some of the after sales systems as well. So if you look into this SPV, it's very complicated to start with a IC engine cars compared to an electric vehicle, and most of the traditional OEM have a big mixture of IC engine cars versus electric vehicle. So when you have a complete autonomous electric and shared mobility in future, we can define this TV in a much better way. But as Alex said, most of the OEMs have started this SPV, journey very recently, apart from the tech companies or startup companies like Tesla. And there are a lot of advancement in this topic. So you can see, a lot of personalized experience provided by the traditional OEM within the onboard experience. It's also part of an software-defined vehicle and how it's going to interact with some of other systems across the vehicle architecture or vehicle components. So I'd say we will reach there eventually, and we can, compete with the new age companies soon.
Thank you. Alex, the AI models need a large amount of data. How do you collect data from vehicles with keeping customers' privacy?
Yes, two or three different strategy for it. First of all, the data that we collected from the vehicle, I keep private. Some of them we mask them off already, so the privacy information there isn't there. When we do AI learning, there are things that it was privacy information. Usually, what we do is strip it up or substitute that with a different type of data. Otherwise, what we want to do is create and simulate what they call a synthetic data, synthetic images in this context, such that we can train them without violating the privacy of the issue. So there are ways to solve that problem and do not have to stuck the area of where we do not have a lot of commercial data, for example, like battery life or anything alike. then you have to actually create and synthesize some information and use that from that perspective. And use AI, with physics-based and data-driven type of AI model to combine them to create a better experience in predicting battery and so forth. So not only one solution, but there are a few solutions that could work.
Do customers have to opt in or opt out for this data collection?
Right now, it's opt-in. I think it's automatically opt-in. I don't even know that specifically, but I do know that some of them are required opt-in, and there are some laws in some states and eventually required opt-in. But in most contexts, I believe that eventually most people like the experience and want to increase their experience with the vehicle. So the automatically up in, like, Tesla, so people up in a lot more than Toyota. But I believe that up in. But if we as a company are consciously protecting the consumer privacy, yeah. So those are the safety factor will be very held in high regard.
James, do you have anything you want to talk about on that topic?
So at most of the OEMs, this data which is either generated by the car as a connected car probe data and the data what you have on a dealership or after sales network are being handled by different set of organization and verticals. And based on the kind of compliance they follow, they may mask the data and provide as an input to the GenAI tools. And we took an extra care on not using a personal data from different regions which are compliant to a GDPR, and we don't want to look into certain patterns of data which can even connect with the customer details and information. So we are being extra careful on this data handling while working on the GenAI models.
Thank you.
Yep, similar.
Here's a question about innovation and the legal industry. Now, innovation is great, but you have the legal industry catching up. Have you seen the legal industry catching up with these innovations? With all the connected devices and data gathered, it seems like there are concerns about liability considered or that. Not just for the individual, but for the businesses as well. You've kind of already talked about a little bit about that in terms of the privacy story, but are there any other legal issues that you see coming up because of AI?
Where I think about as more ethical AI, responsible AI, and AI safety, if we deploy AI, how safe is that AI? It does even explainable on how the output of that AI will work. Of those areas, so those could be considered legality in some extent on what depend on how do we use the AI for it. So I'm not an expert in legal for it, but I like the subject of AI and AI safety because I think when we deploy, we want to make sure that the output of the AI is quite explainable and see the result of it. Yeah.
Okay, thank you. James, did you have anything you wanted to add on that?
Yeah, Bruce. So if you look into the content generation, which are being used on different verticals at OEMs, the generated content, whether they are being affected with the copyright or some set of regulation that are not known to us at this point of time. So, for example, if you're generating a net new content for a marketing and sales brochures or product brochures, this content might be generated using different set of data, and certain persons might have copyright with a similar set of data. So, we are not sure whether we'll get into a lawsuit on using some of the image generated using generative AI tool or the content generated using generative AI tool. So that's something which we can get into a legal dispute without knowing the complexity of AI generated contents.
Very good, thank you. Last question. James, I asked you a little bit about what's the future look like 5 years from now, but I'm gonna stretch this out a little bit for Alex and ask you, how will the auto industry be using AI 10 years from now? And where will it be used most?
Okay. 10 years from now, I believe AI is still most is in the area of a vehicle design, automatic driving. Those are the area probably will be most concentrated there. You have Gen AI and ability to use Gen AI in all application on the enterprise operation and as well consumer experience. However, a lot of area that still have yet to be uncovered. Logistic optimization, the vehicle design area, the material discoveries. That opportunity there in 10 years from now that we have to use, and AI are not only only in that sense, but when you think about it, if you robotic and assembly or manufacturing, that's another form of AI that could take off very quickly in the next 10 years or so. So those are the potential area that I'm seeing there. I see fundamentally OEMs will need to be changing and transform itself. The one that not adaptable and not changeable is go the way like, you know, the Kodak word at one point. It may take years, but eventually it won't be pretty.
Yeah,
So
yeah. James, last word from you.
So I think as Alex mentioned, it's very important to be adopting AI at this point of time. But if you look into the digital maturity of different verticals within an OEM, all may not have a similar digital maturity. So marketing and sales being a customer facing, vertical, they might have a higher digital maturity comparing to a manufacturing, where the digital maturity might be, comparatively lesser. So we should identify the areas where the generative AI or AI can excel with the business pain points or business cases right now they have, and try to build application or product which can excel in that specific area. So that's my thought. So as Alex said, there are a lot of opportunities in vehicle R&D, especially in connected and autonomous sector and marketing and sales, but there are a lot of other areas like manufacturing, the purchase department or different department in the OEM, where we can progressively build AI tools and help to accelerate the whole product development and streamline the operations.
Very good. Alex and James, I want to thank you very much. James, you've stayed up late, the latest out of all of us, being in India. Alex is also an early riser in California. For the next set of speakers, we're going to Germany. First speaker is going to be right here in Ann Arbor. The last one will be in Germany. So we're going global here today. Again, thank you very much, guys. Very good insights on the topic, and we're looking forward to continuing the discussion for this topic, because we're really at the beginning. And as you both said, we're both at the beginning of this journey with AI, and it's going to be a fascinating story going forward. All right, take care, and we'll talk to you next time.
all right.
Thank you,
Bruce.
Bruce. Thank you, Alex.
James.
Thanks.
All right, bye. All right, welcome back. Our next speaker is not from India. He's not from California. He's not from Germany. He's from here in Ann Arbor. And his name is Alex Euler. He's worked with SBD Automotive for 9 years, guiding their automotive presence in North America, working with clients throughout the automotive ecosystem, including manufacturers, tech companies, and suppliers. He previously managed and continues to contribute to the SBD Automotive software-defined vehicle and artificial intelligence AI research, establishing the company as an industry thought leader in the broader technology ecosystem powering the next generation of transportation. Alex began his career as a developer and solution architect at a major mobile network operator. After receiving his computer science degree from the University of Kansas. I've got a note that says, am I not sharing? Okay, let's stop the share and start again. Okay. All right, welcome, Alex.
Awesome. Thanks a ton, Bruce. I'm really excited to be here at the U. As Bruce mentioned, I live here in Ann Arbor, but I did not graduate from here. I'm a Jayhawk through and through. So for those of you in here who are Wolverines, Trey Burke is a name that's not allowed anywhere in my household. There's very few of you who probably get that. But anyway, I figured I'd start with an inside joke. Again, really happy to be here. I've really loved James and Alex's presentations this morning, hearing from Nissan and Toyota. You know, that's sort of the inside game that you're hearing there, how they're thinking about this, the AI transformation. We're going to talk a little bit about some of the things that they've talked about, just kind of high level perspectives, but then we're really going to drill down into the customer experience of AI, because that's what's really nascent. That's what's fledgling. That's where there's a lot of experimentation, learnings, and risks for automakers. So we've done some real world testing on this with some partners, and we want to share the findings of those tests with you, and as well as leave you with some actionable guidance on how to sort of design and develop intuitive user experiences using artificial intelligence. Just a few notes about us, because I'm sure you've heard of Nissan, I'm sure you heard of Toyota, you may not have heard of us. Bruce did a great job of just high level introducing us, but SBD Automotive is a global team of researchers, technology junkies, industry professionals, and our entire reason we exist is to help the automotive industry develop safe, secure, seamless, and sustainable mobility. So every research project that we take on, every consulting project that we do, we're always tying it back to making sure that, you know, the cars that we're building and the transportation and mobility outcomes we're pursuing are really safer for both drivers and road users, are more secure from cyber threats and theft issues, enabling seamless user experiences, and then transitioning to zero emission vehicles globally. Underneath that, there are some ingredient kind of expertise and skills that we bring to bear here. That's around connectivity, automated driving, electrification, security, software-defined vehicle, artificial intelligence. I think it was Alex who talked about, or sorry, James who talked about CASE or CASES, one of our classic industry acronyms that we can't seem to get enough of. We've got about 18 people here in Ann Arbor with a global team around 120, and we work with pretty much every automotive manufacturer sans Tesla. So you can see our kind of logo list there on the right. If you want to have a conversation, or if you're part of any of these OEMs, you might already have access to a lot of our research. So happy to trade notes with you either online or here in person after the conference. Just one last note on the company before we get into the good stuff. We are publishing on AI and automotive. So next month, or actually in November, we'll be publishing our AI and automotive guide. This is really our encyclopedia of everything there is to know about artificial intelligence in the automotive industry, from use cases to technologies to strategies to actionable insights for different types of companies, all the way from the automaker down to their partners, ecosystem and supply chain. We also publish an innovation guide that assesses different technologies and their potential impact on automotive. AI and its various flavors or sub-technologies are included in that, things like neuromorphic computing, et cetera. And then, you know, today we'll be talking about actually just an insight we published on the consumer experience. We also do some custom work with our customers. There's some examples on the right. I'm not going to go into detail on this, but if you want to figure out, or if you want to find out more, just find me on LinkedIn or email, and we can talk. So I think one of the things that kind of became clear from the first two presentations today, and I'd really like to underscore, is this idea of artificial intelligence as an ingredient technology. It's not developing an AI product as an automaker. You aren't developing something that is a core AI product for a customer. It's something that's layered into every element of both the consumer experience as well as in the way you run your business. So there's our giant chart here, and kind of the point is that you can't actually read all the things on the outside in this view. You can see ADAS and AV, but we've sat down and really looked at the full life cycle of the vehicle, both from the consumer-facing use case point of view, from shopping to buying to driving, charging, maintaining, and then on the business side, including the entire product development lifecycle that James outlined. So lots of implications here. Many of these were touched on by the first two presenters, but I think for today, we're really going to be focusing on the consumer-facing use cases because I think there's some really interesting points that the industry needs to consider before going all in on this technology. And we have some real-world findings to help to quantify that. There's also, some early findings from automakers who are experimenting with AI technology across their business. So just an aggregation of our insight here. We've sat down and looked at many of the major automakers. It's not exhaustive it's not exhaustive, but relatively comprehensive in terms of depth, and said, okay, for each automaker, what are the use cases that they're exploring or productionalizing from an AI technology point of view? And what's the maturity of that deployment? Is it something that they've been doing even before the AI boom powered by generative AI? Or, is this something that they're just now dipping their toes into? And, really, I don't think that there's a ton of surprise around what you see in this chart, especially with companies like Tesla and BMW being in the upper right quadrant. But what we're seeing is really an expansion, a rapid expansion to the right. So lots of experimentation across the enterprise at relatively low maturity. This is because the return on investment in AI has not been really fully quantified across these use cases. So automakers are really spreading their bets, experimenting, trying to better understand how AI can be used to improve their business or the experience. And then once they have some initial findings, really doubling down on those where they see a net impact there overall. And when we actually look at the data across both the business and the consumer use cases, we can see that research and development, some of the topics that James talked about, really leading the charge in terms of the deployment of AI technology within the business. And then on the consumer side, really around the driving experience, especially in voice. And this is one that we're going to talk about in a bit more detail. If you'd like more insight or explanation of how we got this chart, that's something that's going to be detailed in that AI for Automotive guide. I'm happy to trade information with you on that after the talk. And of course, most automakers aren't doing this alone. You heard from Alex how they're partnering with AWS as their key cloud partner for AI technology. Pretty much every major tech company is involved here. Microsoft with its partnership with OpenAI, and they also have a lot of different new cloud services in Azure. Google and the Google Cloud Platform being a major enabler, and Google being one of the early leaders in machine learning technology with TensorFlow and its contributions to the open source community there. NVIDIA, obviously, from a silicon point of view, the new Rivian architecture will be powered. Its autonomous driving capability will be powered by the NVIDIA Orin chipset, which actually is a major step change in terms of neural processing capability in the car. And then in China, of course, companies like Baidu and Huawei very much involved. Some other companies you can see there, especially domain specialists in voice like Cerence and iFlyTech involved, but way more kind of below the surface of the iceberg there than we have time to talk about today. One other really interesting insight I just wanted to talk about before we get into the customer experience detail is, last year around the Detroit Auto Show, we hosted a dinner with some executives from some of the tech companies, so Google, Apple, Amazon, kind of sitting in the same room with some of the leaders from automakers. And this was really when the conversation around AI strategy was heating up at the top level of each of these companies. And there was a really interesting comment from one of the tech folks, and they said, we don't think about AI as kind of a standalone function within the business. We think of it as a competency that's spread across our product and engineering organizations. And then every product owner in our team, every thing that we develop, whether it be for a business or a customer, our product owners are equipped to understand the different tools that they have to enhance that experience, to enhance that product with our AI engineering capability. That includes both the fundamentals of machine learning. So how can we train a specific model or enhance a specific function with a unique set of data, or those companies also have a ton of your personal data. So based on what we know about our customers, whether you have a Gmail account or an Apple ID or an Amazon.com account, they're going to know a lot about your buying preferences, your mobility patterns, where you go on the internet, and they can put that to use in kind of understanding and developing kind of more personalized experiences across those products. So this is a fundamental challenge actually for the automotive industry, because OEMs are never going to have that level of data available to them to curate the customer experience. This is why, frankly, you're seeing a lot of increased conversations, partnerships between OEMs and tech partners, because there's kind of an acceptance that, you know, if you are a GM or a Rivian or a Toyota, you simply don't have the fidelity of data, and it's going to be difficult to get that data, especially in a world where you're serious about protecting the privacy of consumers. So interesting anecdote that I kind of wanted to share as we frame out this conversation. Some quantification here in terms of those KPIs. We talked about OEMs kind of experimenting along the breadth of use cases. Certainly, we're seeing a lot of activity on cost reduction and agility. 19% energy saved in the paint shop through AI analytics, 20% time saved in code writing using generative AI. Mercedes-Benz was one of the first to experiment here. 40% decrease in the need for advanced prototyping by using AI simulation. This is exactly kind of the design prototyping that James talked about in his first presentation, and a 99.9% reduction in the cost of simulating vehicle drag coefficient by using AI. So really this idea of using AI to support simulation of different designs and scenarios, kind of being one of the early leaders of a clear ROI, especially in generative AI. On the customer side of this, again, very early days, especially because of the hallucination risks. That's very much dipping toes in the water rather than going all in. But Mercedes-Benz was one of the first to put ChatGPT functionality in the car as an experiment, essentially, and they saw a 2 times growth in the usage of their Hey Mercedes in-vehicle voice assistant for the people who opted into the ChatGPT beta. In addition, Skoda talked about a 90% accuracy level achieved in detecting engine issues using AI sound recognition. So this can help really, enhance the service and maintenance by supporting predictive maintenance functions by detecting different data sources. And then obviously on the revenue generation side, the holy grail, every automaker, Tesla talked about a $300 million insurance premium run rate during 2023, which relies heavily on their own AI analytics capabilities. So just a few numbers here to help quantify kind of the spectrum of where this experimentation is happening. But major challenges do remain. I know that James talked about these briefly, and like him, I'm not going to go into all of the detail here because we really wanted to focus on the test results from our consumer testing. But certainly, AI regulation is going to be something that automakers must pay attention to, and to ensure compliance with whatever is brought to market. And especially on the consumer side, also ensuring that data privacy concerns are respected, and perhaps also a way to differentiate. This is how Apple sort of differentiates itself in the smartphone and consumer product market by saying, your data never leaves Apple. If you're an iPhone user, you always have the option to not share data with an app on your phone. So, this is one way for automakers to also consider differentiation. There's a question around insourcing and outsourcing technology. Alex talked about how Toyota is partnering with AWS. On the complete other end of that spectrum, Tesla is spending billions a quarter to build out their own sort of AI data center in Dojo. Of course, there's multiple reasons for that, considering they have their own in-house or partner AI company, XAI, funded by Elon Musk. But nonetheless, I think it is not a consideration. As AI becomes more critical to the business, are you willing to put a supplier as part of that point of failure? Kind of toward the last point there around the silicon supply chain and TSMC. The cost of compute is a big deal. I mean, if you're going to spend money on the compute, you have to have a return on investment, sustainability targets. I think James talked about a major concern for myself personally around going really far in on this. And then an interesting one that we didn't talk a lot about is model poisoning and cybersecurity. So if you're getting bad data inputs to the models that are being trained to support these use cases, the customers are going to get inaccurate, or the business is going to get inaccurate information that could lead to poor outcomes, whether it be for safety, security, or simply poor customer experience. So That said, I'm going to take a step back and talk about the customer experience specifically. For those in the room, I'm curious, show of hands, who's been to CES before? All right, so I've got 3 or 4. Okay, I would say about 15 to 20% of the room has been to CES. For those of you who haven't been there and are involved in AI in any sort of way, I would try to find a way to go in 2025. It's the first week of January. Registration just opened because 2 reasons. Number one, it's half an automotive show. Like half of the show is all about automotive or somehow related to automotive and mobility. Second one is that AI has taken over the darn thing. So when we were there in January this year, we walked through every single booth that automakers and their suppliers have, and without fail, there was at least one demonstration around generative AI in the car. And we expect that very much to continue this year as part of OEM presences in the show. We go there every year as a company. We produce a huge report on it, and we always try to identify the theme. Going all the way back to 2018, we've said this was all about the personalized car, and then Shy technology, new audio experiences, augmented reality, immersion, practicality. But last year was all about the conversational car, and really the theme was AI for all. We still are not yet fully in the trough of disillusionment for AI, and I think that we're going to see really a continuation of that theme in 2025. So with that context in mind, we saw a massive need to better understand how consumers best interact with and how you can best design an outcome around AI-enabled experiences such that you're not turning off customers to the technology and you're improving the use case overall. So we partnered with a company called Pulse Labs. I'll talk about them in a minute. But really, there were 2 things we did. We asked participants to complete 4 automotive-related tasks using an app or a website, just going into your Chrome browser and doing it that way. And then attempt the same using an AI-enabled or an LLM-based AI like ChatGPT or Gemini. At the time, it was called Bard, but we'll call it Gemini for the purposes of this presentation. Those 4 use cases were buying a car, troubleshooting a dashboard light, Bluetooth pairing, and planning a long trip. So actually 2 different types of interfaces here, right? One is outside of the car. Maybe you're using your phone or your laptop to evaluate potential car buying options. But then also within the car, you might want to troubleshoot a warning light, pair your Bluetooth, etc. So we tried to cover both of those particular use cases here, and we'll talk about those in a bit more detail. The way that we designed the study process was we recruited real-world study participants here in the United States. They went through these use cases and actually recorded their screen and audio for future analysis, so it was entirely a remote study. And then after that, we ingested the video to sort of interpret that and then analyze sort of the results. And we also asked the study participants questions at the end around the experience. So, before and after, what was their acceptance of the technology? Was it a better use case? Was it a worse, etc. And then, of course, we took all of that aggregated data, analyzed it, and prepared this report that I'm about to talk about. I just wanted a brief aside about kind of our partner on this technology, on this study, Pulse Labs. So at SBD, we're researchers, we're analysts, we're data junkies, we're UX nerds. So, we've been doing this for 10 plus years, and we understand how people interact with their car. But Pulse Labs, our partner here, they actually work with companies like Google and Apple to design and test their AI interactions. So very much involved with the market testing for Gemini, Apple Intelligence, etc. So we work with them to say, okay, based on what you've learned in your work with these companies and our understanding of cars, how can we start to create a narrative around what people in their cars or interacting with vehicle technology want with AI-enabled interactions. I'm not going to talk too much about this slide. This is just for the data junkies out there who care about this. We had 78 participants in the study, relatively even distribution amongst genders, leaning a bit more towards Gen X and millennial respondents because that represents the core car buying demographic at this point in time. and generally more entry-level and mid-level vehicle type owners with a few luxury overall. But for most of them, 2/3 of the respondents had not used AI technology at all whatsoever. That's maybe the most important data point to consider here, because that'll inform sort of, what to take away from some of the questions we've asked. And the one that I really wanted to spotlight first and foremost was that after all of the participants went through, the intention to use AI to support these tasks in the future was very high. So through the current capability of Gemini and ChatGPT, they said this was actually a great experience. This was much better than trying to do these things via a website or a separate application. Learning about the specifications of your vehicle, nearly 70% said AI was the best way to do that. And then on the other end of the spectrum, ones that actually involve taking big, important decisions, like what car are you actually going to buy? Somewhat less of an uptake, because I think there's very much a more human element to that decision overall. But you can see here that overall, the customers were very much intended to buy the car. So I want to spotlight 5 key findings from this, and we'll talk about each one in a little bit more detail. But number one, and this last chart kind of quantified that, the barrier to acceptance is low for generative AI amongst consumers. Number 2, users favored AI for its speed, specificity, and personalized responses compared to having to find and interpret that information yourself. Third is that users are developing a sense for when they trust AI. So that trust is not absolute. It's a matter of, can I trust that I am getting accurate, non-hallucinated information that's well sourced that I can go dig into deeper if I want to. Fourth is that, if we look at all of the different kind of type of AI users, we've developed a very core demographic of situational believers that, aren't necessarily pro AI or very much invested in making AI part of their daily interactions, but for very specific use cases, if you design it right, they're very much willing to interact with the technology. And then fifth, and perhaps most importantly, building on that, is that the correct execution of the use cases can lead to high engagement. And we'll share a couple of core sort of tenets of that at the end of the presentation. But just to quantify the barrier to acceptance, one of the key questions we asked was, after the experience of navigating through those use cases, would you prefer to use AI to find information related to vehicles? 72% of our respondents and our test participants said yes. And actually with an interesting quote here from a Honda HR-V owner, I preferred AI because it brought the information to me with minimal effort. It was accurate and concise. It saved me a whole lot of time and searching. So the key word there is time, right? People are interested in using AI in this context, generative AI in this context, as a time saver. You don't have to interpret and synthesize that data yourself. The AI kind of interprets it for you and then tells you really the need to know information. And you can see there on the bottom right with the green, really the overall preference, again, kind of that number there, 72%. So pretty remarkable overall. The second finding to highlight here is this specificity and speed. So there's actually an embedded video here. I'm not going to play it. And in our kind of report that I'll link to at the end, you can go and download this. They are embedded in that. You can watch it, but the actual kind of person working through the use case. But on the specificity and speed side, it's understanding and explaining succinctly the why behind the problem. And that was one of the verbatims from the test takers. So whether it be accuracy, up-to-date information, task-specific tools, references to official sites, so you know that the data it's using to inform that insight or that finding is accurate, and reliability through community vetting. So this is, we always look at Google reviews, Yelp reviews, other sources of Angie's List, other sources of information to validate that we're making the right decision. AI can do that, and it's very much an important part of that user experience to ensure that there's a level of trust and specificity to the findings of the AI. Wanted to call out one of the other sort of verbatims here from Hussein, who drives a Camry. He said that the first task was about which vehicle suits my needs. It had a more comprehensive tool which asked many questions, which made me think it was more personalized. So we'll come back to at the end, some of the UX kind of direction, but this is a really important comment because prompt engineering is a really big deal in generative AI. And not the average person may not be able to prompt the AI well enough to get to the exact outcome they're looking for the first time. So making that really a conversational experience, understanding the context of what the person is asking, and then prompting them for more information, guiding them along that particular use case is going to be a really important point, especially when it comes to experiences that result in a decision being taken or a referral being made. The third point is that trust in AI is not absolute. So just because ChatGPT tells me exactly, it gives me my route plan for a road trip, I'm not going to take that at face value. There's always going to be a need for sourcing and annotation within that response. So even in the implementations of ChatGPT and Gemini, our respondents in general felt like critical information for decision making was missing from the AI responses, as well as a lack of logic. This is one that's going to be a lot harder to overcome, especially for more complex use cases. This comes down to the fundamental reason that generative AI does not have reasoning capability. It doesn't understand necessarily what it's saying. So when it comes back to that causal relationship around cause and effect, and being able to form the logic for that, that's where the technology trips over itself, and there needs to be extra diligence and care in applying generative AI to use cases where understanding may be required to get to that core finding. So you can see some of the data here charted on the right. We asked respondents to rate ease of use for these different use cases versus the trustworthiness of response, and found that even with this consideration in mind, actually there is a relative higher level of trustworthiness and ease of use in the AI responses versus the app or website. One of the reasons for this also is that when you're using an app or website, you know directly what the source is, and that could sound some alarm bells around bias in that response. So if I'm trying to make a decision around what car I want to buy, and I go to the Nissan website or the Toyota website, GM website, whatever, I'm getting that information directly from GM, and there could be kind of bias that's trying to convince me to buy this. There's a certain level of trust that AI is actually looking at the broader context, more objective sources of information, and trying to aggregate the finding to what the average answer is for each particular use case. So that's one important other sort of advantage here to consider in this context. Two verbatims we wanted to share from Thomas, who drives a Subaru Impreza. The results were okay, but I expected more logic. Why should I stay 2 hours in a hotel when I plan a 3-day trip? This is the core hallucination problem. It's recommending something based on the average, but may not be able to look at the forest for the trees and say, okay, does this make sense as an end plan for the customer? And then Alexis, who drives a Hyundai Sonata, I feel like it was good overall, but didn't tell me enough about the vehicles that it was showing. I feel like it was missing important information like pricing. So this also goes back to point 2 around having a responsive interaction design, prompting the person for more information to make sure that the finding or the output is as relevant as possible to the information that they're trying to get to. Number 4 is that amongst the 78 respondents, we were able to identify some really interesting demographics here. We've kind of bottled the 78 people into 5 groups. Naysayers, people who really don't enjoy the technology, they don't trust it, and they aren't satisfied. Believers, very, very small group. Situational believers, which I talked about a little bit before. Skeptics, who are open to it, but don't necessarily trust it, don't really trust the technology. And then preachers, who really are evangelists behind AI technology and what it can do. So if we map those different demographics to the kind of physical demographics of the respondents, on the situational believers side, these were really actually frequent users of generative AI, so ChatGPT users, maybe subscribers even, and these trended a little bit younger, millennial, Gen Gen Z, over 70% of these were entry-level or first-time vehicle buyers, which represents sort of the early car buying market. For the luxury vehicle drivers, these tended to be older respondents, Gen X plus, and are more likely to be skeptics or naysayers. And really 50% of this group more hesitant to use or trust AI. And then if we look again at the generational groupings, Gen X plus and Gen Z, Gen X and Gen Z were the two dominant segments in both the preacher and naysayer clusters. So really a lot of sort of fragmentation within those generational clusters, with millennials sort of kind of being in that situation of believers overall. So all that in mind, we kind of wanted to wrap it up to say there are a couple of really important things that we need to keep in mind around executing the use cases. Number one, leverage bi-directional conversations and implement suggestive AI tools. So if for whatever the use case might be, you can get more information to make the response more accurate. Prompt engineering in this particular context, and especially like in the car or around use cases that result in a decision, are going to add a lot of satisfaction for the customer and make it kind of the superior technology versus sort of manually looking up of that information for the customer. Secondly, is that contextually embedding audio visual materials alongside other relevant links and apps adds value. So it's this idea that the trust is not absolute. If you have something you can see, you can hear, you can interact with alongside what the AI is saying, it gives you more confidence that what you see there at face value is accurate and useful overall. So a couple of videos kind of explaining these. Again, suggest downloading the report and looking at these in your own time so you can see exactly how the test respondents interacted and how that happened. And back to the concerns, each of the people that responded identified some of those concerns that we talked about before, privacy being far and away the biggest one. So whenever AI is being integrated into your products, whether it be part of the vehicle experience, part of your CRM, part of your kind of website technology, as part of the car buying or car shopping experience, making sure that people understand that their data is being protected and or how that data is being protected will be really important. The second part of that is also just ensuring sufficient training and testing so that inaccurate responses are minimized to the greatest degree possible. There's kind of a famous anecdote from earlier in the year about how an AI chatbot at a dealership website, a Chevy dealership website, ended up selling a Tahoe for $1. Or promising a Tahoe for $1. So these are the kind of considerations that need to be taken into account overall. And also some crazy ones like worrying about losing control. I mean, at this stage, I think that's more of an iRobot proposition for the level of AI technology that is possible within cars. But nonetheless, the skeptics, naysayers, there are fundamental misconceptions around the capability of the technology as it exists today. But who knows? They are possibly important considerations in the long run. And just a couple of more verbatims there, but for the sake of time, I think I'll skip by those for now. So putting this into a kind of a big picture, pretty bow, we sat down and workshopped, whiteboarded some ideas with the Pulse Labs team and really came up with 7 core themes that we ask you to walk away with as you're thinking about your own enterprise approach to incorporation of AI technology as part of the customer experience. Number one is that it must be user-centered. So that design must be user-centered. And this is validated by the fact that pretty much every conversation between a tech leader at Google or Apple or Amazon, when they're sitting down with a CTO or a CPO at an OEM, that's really where they start those conversations, is what are the customer outcomes that you're trying to drive. Number 2 is safety and minimization of distraction. So the AI cannot be distracting. It must be intuitive. It must be like talking to a passenger rather than kind of its own separate use case. The third is that it must be clear and usable. Fourth is it must be consistent and sort of standardized. So when every time that customer interacts with that interface or the chatbot or the voice assistant, the experience is basically the same. Fifth is personalization and adaptability. So being able to understand context of who's driving, what they're trying to do, where they're going, what tasks they're trying to do along their route that particular day. Sixth is around performance and reliability. So some of the connectivity challenges, balancing edge neural capabilities with what's in the cloud. Google just made some significant announcements around Gemini Nano, which will help optimize the capability of things like Google Assistant in the car. And then seventh is around privacy and data security. So not just talking the talk of saying we will protect your data, but also kind of walking the walk and explaining, okay, here's how we're protecting your data. Here are our data sources. Transparency in that kind of conversation is going to be paramount, both for regulatory compliance purposes as well as gaining the trust of customers. So with that, I'm going to wrap up. I'd love to open up for some Q&A. Just a couple of links to walk away with that I'll leave up for us. Well, I won't leave up because we'll go to video, but a couple of QR codes if you want to scan. If you want to access this full study, you can go to the URL that will be in the mail out or scan that QR code. If you want to learn more about us as a company, connect with me on LinkedIn, email me. I got cards. I'll be around until the end of the conference. And if you just want to stay up to date on what's happening in automotive, we publish a weekly newsletter. You can go to sbdautomotive.com/subscribe or scan that QR code to get hooked up. And the last thing I'll note is that for those of you in here who work for automakers, you probably have access to a lot of our research already. So feel free to ping me and I can get you hooked up with the right resources there.
Great. Thanks, Alex. We appreciate your taking the time to present the results from your research. And if you want, we can post a link to the presentation. We'll have the presentation up, but if you want to put a link to the report, we could put that on the website with your presentation. All right. What do we take away from this? Sound recognition, that struck me. Being able to tell what was going on with your vehicle by listening to the sound of it. Now, a trained mechanic can do that, but to have AI do that, that's one of those things about prompt engineering. To actually be able to ask a question that AI can answer in a way that I didn't even think about asking that question. That's fascinating. And the other one is model poisoning. That's a new one for me, where you're looking at what, and it makes sense. We talked about this earlier. It has to do with the hallucinations, and it also has to do where does the data come from that we're using for these models. Yeah, I think some very good stuff there. To start out with, can you describe a little bit about the Tesla $300 million story?
That one I actually don't have the details on. So that one I've got a number from our AI research team, but I couldn't get into details on that one. I'm sorry, Bruce.
What's the basis for it? Do you know?
I assume my working assumption is that it's really around better understanding of the risk profiles for their drivers. So it's very common, this concept of usage-based insurance, where you can kind of detect, and this is also the basis of some of the trouble that GM is in right now with the FTC and FCC. But the idea that you can kind of detect people's driving patterns, right, and then more accurately assess the risk of that driver and charge them rates accordingly. Mm-hmm. So Tesla has this capability. They've got their own captive insurance program, and they've been able to train some of their own models to better understand driving patterns and how that relates to crash outcomes or claims, right? And maybe optimize that a bit more than you would by going through third-party insurance or for them kind of working with a third-party underwriter. Whereas the traditional insurance industry, you're paying a rate based on your demographics rather than your actual driving patterns. So it's the idea is that with usage-based insurance, as a consumer, you're paying less, assuming you're a safe driver. And as a kind of insurance provider or as an actuary, you have better understanding of risk. So you can be more accurate sort of in the rates that you're charging to your customers and optimize your profits and costs that way.
Very good. Thank you. Now, one of the other things that struck me was when people were researching cars, and one of the respondents said there are issues with. I thought I should have pricing. and maybe I didn't have pricing information. Now, there is pricing information on the web. You know, Kelly Blue Book, JD Power, Edmunds, they all have pricing information, extremely detailed pricing information. Is that because they weren't able to scrape that information from those websites? And it kind of leads to one of the questions that we started out with. You know, there's a July article in the New York Times that said that new research from Data Provenance Initiative has found a dramatic drop in content made available to collections used to build artificial intelligence. And so are you seeing this in your work? It makes me think that the pricing stuff was just not available, which is why it was not included when they were doing this analysis with were they using Chat GPT and Gemini, right?
Correct. Yeah, that's right, Bruce. It was Chat GPT and Gemini, but at the time we did it, it was still Bard because this was a few months ago. And you know, I have to go back and look at the video for that particular use case with that particular customer to know for sure. But I have two theories here. Number one is, to your point, that the data may not have been available in the channel that they were working with. So, and especially with Chat GPT, the training data they used for that at that point was frozen in time. So, you know, if you're trying to find information on a 2024 model, Lincoln Nautilus, right? But the training data there was frozen in 2022 or 2023, and that's very new information. The model's not going to have access to that pricing information. But it goes to the second point around kind of engineering AI interfaces to the use cases that it's supporting. So if you're putting a chatbot on, let's say the GM website, you're going to be able to train that chatbot with the exact information that you want it to present to the customers in that interface. So yes, that should include pricing information, but it probably won't have pricing information about competitor vehicles. So that's always something to consider around like the engineering of those prompts. And also as a customer, you know, you have to have a certain expectation around what information will or will not be available based on who's providing that interface. I hope that answers the question, Bruce.
Very good, thank you. One audience question, when Gen AI is widely used, how should OEMs and dealers change sales and promotion and advertising strategy?
Well, first of all, I think dealers need to kind of better understand what generative AI is to begin with. If you look at kind of customer relationship management, so DMS and CRM providers that actually provide the technology into dealers to run their operations, they're the ones who are sort of incorporating AI enabled capability into that. So, you know, they're looking at different consumer data sources, some great, some maybe less than ideal, right? Data brokers, et cetera. And then, you know, helping the dealerships themselves create more targeting campaigns. And I think more kind of predictive or responsive campaigns based on you know, what's being detected either in the market or based on kind of individual customers and the interactions that customer has with the dealership. So very much on the personalization level, but also depends very much on the tools that they have from partners like you know, Cox Automotive, Xtime, Salesforce, those types of companies, and then the data sources that they use to understand the inputs from the dealership and then inputs from individual customers, but really around personalization.
So I think one of the other questions that we had was, I think you may have already addressed it. Why did AI fail on the issue of finding a car to meet one's needs? And I think you kind of talked a little bit of that. Why do you think that people consider privacy a big concern when they use search engines all the time, which keep track of you through cookies and what's going on?
Yeah, I guess it's important not to generalize too much here. There's certainly a segment of the population that either doesn't understand or just doesn't care about the privacy of their data. You know, for me personally, I care, but I also, you know, accept the fact that in order to have a good internet experience, I am going to need to give up some information probably as part of that journey. So cookies, you know, Google knows way too much about the websites I visit and the emails that I get. And that's just the way it is. But I think, you know, as generative AI in particular gets a little bit more mature, there's really a risk of it entering what's called the uncanny valley. And that's just the idea that, you know, you start to interact with something and it knows too much about you and it starts to creep you out. So, you know, that's when you run into a lot of the data privacy concerns where you start asking questions like, how did it know that I went to Best Buy on Saturday, right? Or how did I know that I planned to go to Costco on Sunday? Did it look at my past patterns? These are the kind of things that flag privacy concerns. And then more than that, you know, I talked about some of the trouble that GM is in. This was really around kind of gaining informed consent from customers, understanding, like making sure that customers understand how their data is being used. Because if they're hit with a premium increase on their insurance because of driving data that they did not know was being shared with an insurance company, that's going to turn you off real quick to that OEM brand. So I guess coming back to the core question is, how do companies manage privacy and security? I think, you know, there's two core tenets I would posit here. Number one is transparency to the greatest degree possible. And I think this follows what you're seeing more in places like Europe, where there are laws around this. I think American consumers are kind of catching up in terms of some of the concerns around privacy that you see elsewhere in the world. But then number two is just being very careful about how the data you do have is used either for training purposes or, you know, for sharing with third-party partners, which kind of moves a little bit around outside of the AI question. But hopefully that answers the question.
Well, thanks very much, Alex. Stick around. We're going to ask you to join in the Q&A for Johannes after Johannes's presentation. Johannes, you still with us? There we go.
Very good. At least I see myself.
Okay. And we see you and hear you as well. And let me give you the quick introduction. Johannes Rickenhalter Hagen from he's the managing director of FEVIO.io. He's been with FEV.io for over 6 years and FEV for 9 years. Received his bachelor's, master's, and PhD at RWTH Aachen University in Germany. Welcome, Johannes. We've had speakers from India, we've had speakers from California, and Ann Arbor, and now Germany. Welcome.
Thank you very much, Bruce. Yeah, it's a pleasure to be here, and so I attempt to share immediately if that is correct, right?
Yep. Go ahead.
Very good. So I hope first of all that everyone can see the screen. We got it. Perfect.
Yeah, we got it.
So yeah, great. So then thank you very much again for the introduction. I'd like to speak and discuss with you about speeding up generative AI in software-defined vehicles. For a little introduction, we aligned briefly upfront that it would make sense to introduce FEV to see what we are doing as a company. So we are a global engineering company, more than 7,000 people worldwide, working in the areas that you can see here. So we are doing vehicle development mainly in the automotive domain, but not exclusively there. We are doing software and electronics development with the sub-brand FEVIO, which I'm also representing. But today I'm also representing the whole company, but also FEVIO. We are doing propulsion development, which means battery electric propulsion, hybrid propulsion, and combustion engines, including fuel cells and hydrogen fueled engines. We are doing aerospace development, so that includes aviation and space. We are doing energy development for more sustainable energy solutions, and last but not least, also techno-strategic consulting for our customers. Again, with worldwide 7,000 people, and maybe some of you know FEV already for long term with a strong automotive footprint, which in the meantime has broadened to the portfolio that you can see here. That just as a quick introduction. Speaking about AI, I think that has been already discussed in the talks before, so I will keep myself quite shortly here. AI as such is not a new topic. However, what we are experiencing today is what we call the third wave of AI with the advent of generative AI with GPT, DALL-E, etc., where the excitement in the public is very high. You can see also from the automotive perspective that OEM and various OEM are aiming for making use of the potential. We as an AVV group, we made an analysis for our industry and of course also our company, and we came up with different kinds of potentials to look a little bit more into details. We basically distinguish between two different areas. One is Gen AI and AI applications where the focus is more on the revenue. That means creating or expanding business or further developing products. This is there are not as many cases as for the other areas, but if the right product, the right business case is identified, it has huge potential of business for all of us. The other area is the efficiency increase, which is more related to the organization, where whatever activities we are doing today are automated, facilitated, or the quality is increased by means of AI. Also, we have seen some examples in the presentations before about the potential. This is applicable to any activities. We are typically looking at engineering and technology activities, but also some of the strategic elements, which we will see later. So that is the overall introduction. That is where we are. That is how we look at AI. Now, I'd like to speak about concretely what approach do we take in order to make AI happen in software-defined vehicles. Maybe speaking also about why we say introducing in software-defined vehicles, because we see while we have this advent of AI excitement, we also see in parallel a huge trend of the transformation of automotive platforms towards software-defined platforms in order to enable software-defined features, such as many of them or many of the AI features are also software-based. And we see that coming together. We see these two streams coming together, and that is why we think it together. So our approach follows essentially three elements, and we call that a holistic approach. We always look at the business, or we recommend to look at the business in order to protect future business if the business is already existing, or to explore new business. We look then on the product side, so we derive what kind of product development is required, and sometimes the product development requires organizational adaptations, essentially towards a software-centric organization. And this is our three-step approach, which in the following parts of my presentation, I'd like to go more into detail for. And that is what we call the AI execution. So looking at the business part, I do not go more into detail because later on we would like to focus a little more on technology, but this is just giving an overview. When we speak about the business part, first of all, we have new chances of monetizing AI. For example, we can offer, or we can have as a business model, for example, personal assistants, which we call subscription-based AI services. We can also improve and increase premium vehicle sales, for example, through personalized in-vehicle experience, like a customized cockpit. And last but not least, there can be even new revenue models, such as remote diagnostics and repair, for example, for the battery of a battery electric vehicle. So this is the business perspective. We can derive from that we need to update the product. You're looking at the automotive product. So on the one hand, it's product excitement, which means bring features into the vehicle that previously haven't been there. Like, for example, the voice reasoning for automated driving, so that the driver interacts with the vehicle to justify on the quality of the of the ADAS or AD functionality. Or what we call feature excellence is to make existing features better, to make the experience better for the customer. For example, a Gen AI-based voice assistant, where today's voice assists have difficulties or are limited by means of features and excitement, this can be improved. We will show a concrete example later on. So this is the business and product perspective. In the next step, I would like to go a little more into detail for the organizational part, where we want to speak about efficiency. So what we are doing, looking holistically at the potential of AI, we see, of course, benefits for strategy development, for ideation, for manufacturing, commercialization. We have seen also some examples in the speech before. Today, I'd like to focus a little more on the technology, which is here put into the center. And there we have identified, working with our global team across these different domains, across all areas of software and electronics development, we are looking at what we call technology efficiency use cases. We have identified more than 40 of them, concrete use cases, which we can break down a little bit to the area of requirements, in elicitation and engineering, to the system development, system specification and integration. We can categorize it into the automated implementation of features, and last but not least, the automated test and release. So there is an there's an automation approach behind to replace yet manual tasks or largely manual tasks, to replace them ideally or to support them largely by AI-based automation. The number indicates the number which you can see here indicates the number of use cases. So that means, based on the experience that we have with the engineering in these different domains across the globe, we identified very concrete examples where we are currently working on in order to increase efficiency. What we found is very important is that these ideas, these new approaches of leveraging AI for engineering, that they are not standalone activities of isolated teams. That is how it typically starts with. You bring people together who have an idea, they collaborate, and they come up with a prototype and with an application pretty early. And then there is a challenge to make many people using it, to introduce it into the company processes. So that is why when we are working with such use cases, we always integrate them in our yet existing, what we call systems engineering backbone. That is what you can see here in the background. Without going too much more into details right now, there are also publications and speeches about that available. We are looking on the technology from a holistic point of view, comprising of different decomposition levels, where we decompose the system into different hierarchy layers, but also different engineering views, ranging from the design to the integration. In this backbone, we recommend to organize processes, how-tos, tooling, even assessments, and we have been doing that for many years right now. And we assign these AI use cases exactly to one of these elements in our backbone, so that once the use case has been transformed into reality, it has been proven to be useful, it is immediately and automatically integrated in the process framework, and it can be experienced by anybody in the company. And that is super important, super relevant in just to make or to go the step from the mere showcasing of AI potential to the large rollout. So that so far is our approach, this three-step approach. And now I'd like to show one project example where this can be experienced. I will start with a short video demonstrating the feature of a Gen AI-based voice assist, and then I will expose a little bit on the architecture and the concept behind, and to show how the different elements interplay. Here is this demonstration, and I hope that the video sound works now. It should, after the test yesterday.
I am cold.
Warming up the vehicle for you.
What's my second appointment today?
Your second appointment today is a barbecue at 6 p.m. located at Königstrasse 32.
Do I have enough fuel left to get there?
You have around 15 kilometers worth of fuel left, and the barbecue is around 9.2 kilometers away. You should have enough fuel to get there and to a nearby fuel station as well.
I think I want to refuel. Tell me the current fuel prices.
The current fuel prices in the area are as follows: Shell, diesel 1.679.
Sounds good. Take me to the closest gas station.
I have found a gas station for you. The closest one is Errol, located at Roermanderstrasse 33.
It'll take some time to get there. Please tell Phil that I'm running late.
Message sent to Phil letting him know that you are running late for the barbecue.
Okay, yeah, so this is the feature which can be experienced by the driver. I think what is special about this voice assistant is that the AI engine behind reacts to different types of commands and different type of input, which is not required to be, let's say, pre-processed or to be pre-configured with certain keywords, as it is yet in many cases state of the art. So this is one concrete example how the excitement for a product is improved. Now, what is behind that, or what is required to make something like that possible? So we have just seen with this small video, what is the feature excellence that the people in the car do have. And this car assistant is an application which is run on an architecture that is depicted here in the center. We have this application running on an onboard ECU in the vehicle. This is I think clear and natural. It's interacting with a command backend which is processed in the cloud. So there is a cloud connection. We pay special attention to having a software and electronics architecture where there are consistent layers, so that the backend hardware and the hardware, which we call here EE hardware, the in-vehicle hardware, are communicating in the right layer, and that we have a separation of these layers for the I/O car assistant. This car assistant can be integrated and operates well if we have already this architecture in place. This is the case for software-defined vehicles. So there it is relatively simple and quick to integrate such features. If such a software-defined vehicle architecture is not yet available, it is still possible to integrate this feature. However, then, let's say in a colloquial way, we call that glue code, the interface between this application and the proprietary hardware and basic software needs to be configured and tailored to the needs. It's still possible. Yeah, it is a little bit more effort, and maybe some features are limited due to, for example, bandwidth of backend connection, etc., which then can be mitigated by certain measures. In any case, it is an architecture serving both software-defined vehicles with a vast feature possibilities, and also today's vehicles by separating clearly and strictly software and hardware layers by consciously made architecture definition. Then what is also important, I spoke about that before, is to make really use of the potential of Gen AI. We need a back-end connection. So for this, of course, it's not, or there is no business case behind programming that or reprogramming that by ourselves. So here we aim for integrating the frameworks that exist. So here it's very important to establish the right partnerships between OEM, Tier 1, IT companies, researchers, and even regulatory bodies in order to perform the proper integration. It is even possible to avoid a back-end connection and to run the command back-end in the vehicle, because there are already solutions available with large language models which can be run in the vehicle itself if the corresponding memory and computing power is available. But even then, a partnership is required. There are companies like Cerence that are doing that today. On top of that, a governance needs to be established, because as soon as there is back-end interaction and we have a self-learning system by means of this AI-based back-end, of course, personal data is exchanged, maybe even IP is exchanged. So for this, there needs to be a clear governance by means of rules and monitoring, not only in the companies developing, but also for the running vehicles. So this is something that needs to be put in place, what we are doing as FEV, but that is also happening, and we recommend that doing in all companies. The combination with the software culture, with this governance, basically something, let's say the whole organization made for AI, that is what we call the software culture element that we need to bring in. There are different ways to organize the same. There are different ways to design processes and roles and responsibilities for the same. But the most important aspect is to have a culture where everybody strives for having such an organization in order to achieve agility and to really live true partnerships. I'd like to emphasize this topic because this is in the car industry, for example, in the automotive industry, we are still having a lot of business models which base on selling a product which is essentially a black box where the IP is protected by the producing company. And this transformation towards more partnerships and sharing and generating new revenues, this is something that needs to happen. In the IT world, in many areas, it is already reality. It's coming more and more into automotive. There are also examples, but it still can be more. And that is what we call a software culture. So to summarize, what are our learnings? It's basically the summary of everything said so far. We believe that there needs to be a holistic approach going from the business over the product, down to the organization level. I've shown some examples and concrete activities that we recommend and particularly are also doing by ourselves, ranging from monetization, vehicle sales, revenue models, down to the efficiency, software culture, and governance, which is required. And with that being said, I'd like to close my speech. I'm very curious for your questions, either now or if you have questions later on, don't hesitate to get in touch, like my speakers before indicated as well, through LinkedIn or email. So with that being said, looking forward to our discussion here.
All right, thank you, Johannes. Okay, got some questions for you. I guess the major one for me was the efficiency that you're talking about in creating this a kind of like an AI company roadmap about. Were you thinking about, is this something that you have done within FEV only, or have you done it with customers?
The answer is both. So typically it works like when we are a technology company. So when we see a trend coming up, we immediately analyze what is in for the company, and of course we're working with that. That is, let's say, something natural. However, it has this let's say third wave is already in the market for a couple of years already, so around 2 years at least. So there are customers with whom we are already working in that field. And in many cases we don't even ask, because if we believe that there is an efficiency increase, we do it. Of course, then we let our customers know and we collaborate on the same. And so far, our experiences is that our customers do welcome this attitude. However, there will be more to come. And we believe especially there will be more to come on the product level. What we are seeing right now there is that there is a certain phase of exploration. There are some premium products where AI-based features are already rolled out, but it's not democratized. We call it a democratic, or how to say, brought into the wide range of mass mobility yet. This is a trend yet to come, so we believe there will be more.
Okay, now when you were talking about the subscription services as an opportunity, one of the things that we were discussing earlier in the conference was the cost of implementing AI and implementing the services that you're talking about, balancing that against the potential revenue from those services. How
Yes.
do you guys manage that? How do you look at that?
I mean,
You know,
I mean,
you
on the
have
one,
to set, you have
yeah.
to set up cloud services. You have to set, you know, there's tremendous amount of investment, right, to get to the point where you have that personal assistant, right?
Yeah. So what we are doing is we are doing an investigation on that. In fact, we have been already doing that for customers, because that is a typical question which belongs to the technical strategic consulting that I mentioned before. Yeah.
Mm-hmm.
If there is a company setup where the backend is not existing, the layered
Mhm.
architecture is not existing, maybe also no vehicle connectivity, which is also happening, then of course there is almost no feature where it pays off, where they invest into all of these elements, into all of these required elements, pays off immediately. So that is why we believe there is always a business case if this subscription-based services are implemented on the fundament or on the base of a software-defined vehicle architecture, where the investment is already being made. And there's barely a business case for just doing it for the purpose of this one feature. So typically our customers, they strive for having multiple of these features and also other benefits. And then it's just about speed and the right way of doing it in order to do it with the minimum costs.
I have with us the speaker who presented just before you, Alex Oyer. His group has also been looking at, for a while now, the software-defined vehicle. And I wanted to ask Alex, how do you see the integration of the software-defined vehicle with the AI?
It's a big question, Bruce, and obviously would love to, Johannes, get your perspective once I, trade a couple of mine. I think one of the most interesting actual examples to look at is what Rivian has done with their Gen 2 platform. I would call this really the state of the art, generation leap, more advanced than what Tesla, maybe some Chinese companies are there, but overall state of the art. And what they've done is really consolidated all of the electronics in their car to 7 electronic control units. 2 of these are really powering the AI capabilities in the car. One of them is the digital cockpit, and the other electronic system is for automated driving. And on the digital cockpit side, and for both chips, they've added significant neural processing capability, 250 plus tops. So I think there's 2 parts to this. Really, number one is on the automated driving side of the equation. Optimizing kind of path planning, perception, and where the machine learning is done in the car. That's not really generative AI per se. But then on the other side is the digital cockpit, and that's where the new kind of AI compute capability lives, incorporation of the actual silicon capability. The big consideration here is connectivity and the costs of the data. So if you're enabling use cases at the edge, you're going to have some sort of inference. You're going to want to have some sort of inference capability on that actual module itself. So whether it be for navigation purposes or really for voice assistant, it's sort of enabling that application layer capability, and then using the data inputs within the car itself, whether they be cameras, microphones, or other inputs, to sort of synthesize into actionable sort of, whether they be prompts or actuation of sensors or just a interface on the digital cockpit. So maybe that's the high level, but Johannes would be keen to hear his take as well.
Yeah, I'm glad that you I'm glad that
Yeah.
you're mentioning. So the Rivian architecture, I think, is a very prominent example because it was also, let's say, more publicly announced. Whereas in other cases, let's say as an architecture, whereas in other cases, it is held by the OEM as an essential feature. And I think Rivian, maybe see that also by the recent announcements being made, also follows a strategy of sharing that with other companies as well. Yeah, so definitely I agree. Yeah, so first of all, from the hardware perspective, such kind of architectures, it's not my intention to promote Rivian in particular, but for example, such architectures aim for having the right electronic, let's say, electronic controller network in order to facilitate to roll out software features quickly. For example, it's better to integrate or to run new software components on a lower number of different controllers than we have it today in the vehicles in mass production. Yeah, that is one element. But then also the second element, which is very important, is to have a properly designed software architecture, and that is actually what I try to depict in a more simplified way in the center of this architecture sketch. So long story short, definitely I totally agree with your statement. Yeah, this is exactly these are the type of architectures. Once these are more rolled out for really mass mobility, being dominant in the market, then we will see very low hurdles in order to roll out features like the Gen AI based voice assist. But we will also see that before but just with more engineering effort, maybe with less business case, but it's also about speed and to show product excitement first. We know that from other industries as well. It's not only the mere business case of one feature. So it's a very interesting phase we are in actually right now.
Now, Johannes, Alex, before you was talking about some research that they did recently where they were talking to consumers about and having consumers testing out differences between using a ChatGPT type assistant inside was it inside the vehicle?
It was actually a web interface.
There's a web interface versus doing web searching, and it was one of the problems they had was that the AI couldn't do all the different things that you would want to do for like planning a trip and being able to understand what are the different nuances of planning a trip. Now, the example that you have in your personal assistant, that kind of stuck out to me. You know, so did the AI understand that the fueling station and the trip would make the driver late? Did the AI say, "Oh, I understand that you have this appointment and you're going to be late for that appointment if you go and get gasoline," or did the person decide that? So it's a pretty sophisticated thinking on the quote. Let's put thinking in quotes here for the AI to be able to do that and give you kind of all this information kind of in a bigger context. Is that what it was doing, or was I misunderstanding it?
No, I think you exactly understood it the right way. I would like to say it like that. It's about proper prompting in the end. So the example that you are depicting with the web-based interface, if you don't have any layer in between, it's just about what do you ask the large language model, I think all of us experience that when using tools like ChatGPT. It's about how you ask and what you ask, and you get different detail level and different quality of answers, so to say.
Yeah.
To be very honest, we make the experience that there are kind of weird questions or weird commands people make, and of course there can be further enhancements, or weird in terms of compared to what the AI algorithm needs. Yeah.
Right. Right.
And what we did, and that is part of this AVVIO, what I call AVVIO backend, is that we don't simply take the prompts as they are spoken by the driver in this case, or by the user, but we add some elements to the prompt to increase the likelihood that the AI understands the right thing, so to say. So
Yeah,
there is some
yeah.
experience behind, to modify the prompts or to expand the prompts in a way to increase the quality level. So it's not simply plugging several software stacks together and let it run. That would be super easy, and that in fact is super easy. It's also about to have the right layer in between with regards to prompting. And by the way, there are also some, let's say, timing issues to be resolved, and so that it really operates sustainably and in different occasions and under different loads. So there is some intelligence behind, and this will further develop. Yeah, so there is some, how to say, smartness. I don't know how you called it. It's still required to integrate it properly.
Yeah, because when I was listening to the assistant, it made it sound like it was doing cause and effect, which is something that AI is not supposed to be able to do. That to actually, to think, put everything in context and then say, oh, did you know that this, did you know that you're going to be late if you do this? And that kind of thing.
Yes.
The other thing was, okay, you're short on gasoline. You're going to have enough, you have enough to make it to this trip, but you don't have enough to make it back home. And so,
Yes.
then suggest that you should get gasoline now, or do you want to get gasoline later? We know where to go. We know when the station's open, and kind of taking all that stuff into context and helping the driver make a decision, which is, I think, pretty unique for
I
an
think
AI system.
yes. So apart from the prompt to make this happening, what is also required to have access and to integrate the different, let's say, elements on board. For example, in order to know that there is a birthday party scheduled, you need to have a connection either to the cell phone with required, let's say, rights or access rights, or to the online service hosting your private calendar, basically. For knowing the gas or the fuel level, you need to be connected to the fuel sensor, basically, in the vehicle. That was depicted in this picture where we had this connectivity to the different onboard devices, so to say, and also offboard, like backend, like calendar services. And there it is required to have integration experience to know how the vehicle operates and how this onboard network is configured and how to access the required data. So this is, of course, experience that we have brought in here based on multiple projects that we are doing on a daily basis with or without AI.
It's fascinating the inputs that are needed to be able to make these things happen. And I was very impressed with your description, the graphic that showed all the different layers that need to be in place to make this stuff happen. It was nice to have your presentation, because the other presentations we had were not really talking about this in that level of detail. Now, one of the questions from the audience was, is the voice assistant available now for you to sell to customers?
Yes. I mean, it has a certain stage where we configured it for a demo vehicle that we have, and we configured it for a certain demo platform that we have. So if the platform is different, there needs to be some tailoring. And also we can include more prompts and more variety of prompts. But essentially, yes, it's available. That's the reason why we invest time and capacity for and our experience. So the answer is yes, and we are very much interested and open for further exchange on the same.
Is the voice assistant available in multiple languages?
Yes, as well. Here we follow the capabilities of the AI engine behind. So the demonstration that you've seen is based on the OpenAI stack. If we use other, let's say other stacks behind, there might be different limits which anyone can experience. But let's say the most, let's say, used languages are automatically supported, whatever the engine behind supports.
Okay.
However, it's not the the level to which we brought this demonstrator is for sure a lot tested for English language. So if we tailor that to other languages as well, I believe some fine tuning will be required. But this is not the, let's say this is not the bottleneck when it comes to making it happen. So this is just a routine task, basically.
Yeah. One of the questions was, could it actually do more than one language in the same car?
Yes, it would be. Yes.
Yeah.
That's the power. That's the potential of this technology. Yeah. So I think that is really the new thing that we can enable a lot of features where in the past large teams at OEM and tier one needed to work for years with large budgets in order to make something like that happening. And if you have the right integration approach and the architecture and the right partnerships in place, it's incredible how many features in a relatively short time can be enabled. That is really the potential that is in there. And I think the voice assist is a good example how this can be showcased. Yeah, and there are many more. Yeah.
Very good. Thank you. Now, one of the questions we've been asking the different speakers along the way is, with all the experience in it, I don't want to say all the experience, meaning a few years of experience of working with AI within your business, and you've been looking at it across business units and within business units and different functions within the unit. It was interesting because you were really focusing on some kind of an AI roadmap that would be kind of available for that, I would say, management that is focusing on that for within the company itself. When you look into the future, where do you see the auto industry? How the industry be using AI 10 years from now? And where will it be used most?
Yeah. So it's hard to exactly predict. Yeah, of course, like 10 years is a long time. If I imagine what happened 10 years ago, however, we can say it will be an essential element of certain features. For example, all the in-car infotainment applications that we already see today, or in the past years already, the trend that the consumer electronics world, so to say, and the in-car infotainment has merged quite a lot. We will see announcements of like we already have the Android automotive operating system in place in vehicles such as Volvo. We have in nearly every vehicle CarPlay or Android Auto for basically smartphone mirroring. There are also updates announced already, so there will be some more potential. And now putting on top of that, putting features like the voice assist, it will happen definitely. It will be for certain use cases, for certain features, it will be nearly commodity. I mean, if I speak 10 years down the road, it will be commodity.
Yeah.
What is uncertain when within these 10 years it will be widely implemented and widely distributed, because this also not only but also depends on the capability of the automotive industry to roll out these new architectures like the Rivian one in a large scale. This will be the key driver. If that is going to be really implemented, I mean, we see announcement, the Rivian Gen 2 platform to be starting in 2026. If that is really going to happen like that, rolled out with companies like Volkswagen, there's already a multi-million potential of vehicle sales, but then these vehicle sales need to happen. So we already now are looking some years down the road, but if that is turning out to be a business, then I think this will be quite standard feature in the future.
Yeah, I guess that's the question. Will it be a standard feature, or will it be something that the consumer will have to pay for?
I mean, it's already available. I mean, I can already speak with my cell phone with the Gen AI engine. If I use, for example, the OpenAI one, I can ask my cell phone any question. I believe I believe customers will not.
I meant built into the vehicle.
Yeah, exactly. So I believe customers will not or consumers will not be willing to wait a long time to experience that in the vehicle. I mean, if I'm putting myself in the non-technical view, I can speak to my smartphone already today. I can see, I can mirror my smartphone with CarPlay or whatsoever in my vehicle today. Why should it take years to have the same features available? Consumers will not understand. So there will be a huge pressure, and whatever company will roll out that first on a large scale will have a competitive advantage. And all are striving that for this. It's already happening. Yeah. So I believe there will be a huge pressure from the market. So it can't be a long time down the road. And the question is how quickly and how easily the bottleneck of the architecture can be overcome.
That's right.
Otherwise, it will be very expensive features for maybe smaller amount of vehicles.
Yeah, the architecture thing is the big deal. Being able to integrate everything that's going on inside the vehicle, underneath the hood, inside the vehicle, with what's going on outside, with the addition of that information from outside. That's and as you say, it's going to be the challenge for companies, because it's not there yet, is it? It isn't for the traditional manufacturers, right?
Yes.
Yeah.
It's for the traditional manufacturers, and for the new manufacturers, the question: how much are they able to penetrate the market? So it's a kind of race going on. Yeah.
Yeah. Very good. Let's see. I think that's it for all we have for you today. I want to thank you for taking the time and telling us the FEV story. Was, it's fascinating to see how suppliers are making the transition, either in AI situations, but EV situations as well. FEV, as we were talking in the past, was really considered more of a powertrain company, and it's much more now. It's very many, all these different verticals that you're investigating. It shows you how challenging it is to be in the automotive industry right now. I think that's all we have for you, Johannes. Thanks again for your time, and we'll be in touch later on.
Most welcome. Thank you very much, Bruce, and the audience.
Yes, our cast of thousands. We've got people online, and we've got the people in the audience.
Yes. Most welcome. Right. Thank you very much.
Take care. Okay. So, time to adjourn and let's have some lunch. I wanted to thank our speakers. I want to thank our affiliates. Could not put on the conferences without our affiliates. We always like to thank them. Next conference coming up in November 13th inside China. I hope to see you there. We're always keep an eye out for us on LinkedIn. If you haven't connected with us and follow us, feel free to do that. We're posting 2 to 3 times a week. And until then, see you next time.